Right now, as you lie in the darkness listening to these words, billions of neurons in your brain are firing in intricate patterns, creating electrical storms and chemical cascades that somehow, against all odds, produce the subjective experience of being you, of perceiving this moment, of knowing that you are perceiving it. This is consciousness, and it remains one of the deepest mysteries that science has ever encountered. You are aware of your own awareness, a strange recursive loop that defines human existence, yet neuroscience cannot adequately explain why this happens at all. The brain processes information constantly, filtering sensory data, making decisions, executing behaviors, and coordinating the thousands of biological processes required to keep you alive. But there is nothing inherent in these physical processes that requires subjective experience to accompany them. A computer processes information without experiencing anything. A sophisticated robot navigates its environment without the inner light of consciousness. So why do we experience the redness of red, the bitterness of coffee, the warmth of sunlight on skin, the peculiar sensation of your own thoughts moving through your mind? This is called the hard problem of consciousness, and it may be the most stubbornly persistent scientific mystery of our age. Philosophers and neuroscientists have developed elaborate theories attempting to bridge the gap between physical processes and subjective experience, yet none have satisfactorily closed the explanatory gap. Some argue that consciousness might be a fundamental property of matter itself, woven into the universe like gravity or electromagnetism. Others suggest it emerges from certain types of information processing, though they cannot explain why information processing in biological neurons feels like something while information processing in silicon does not. And yet we have normalized this profound mystery so completely that we rarely acknowledge its strangeness. We wake each morning and assume our consciousness is obvious, unremarkable, a simple byproduct of having a brain, but this assumption is precisely where the deepest question lies unanswered, waiting in the quiet darkness for an explanation that might never come. Perhaps consciousness persists not because it solves a problem, but because it is the problem, the fundamental mystery that forces us to confront the limits of our understanding and wonder whether some questions about existence can never be answered through science alone, only experienced in the quiet of our own minds. And perhaps that is enough, not a solution, but a recognition that consciousness may be less about solving the puzzle of existence and more about bearing witness to it, about the universe becoming aware of itself through the particular miracle of your own eyes, your own thoughts, your own irreplaceable perspective on what it means to be alive. Imagine standing in complete darkness and being asked to map the universe, only to discover that everything you can see and measure accounts for merely 5% of what actually exists, while the remaining 95% remains fundamentally invisible and undetectable to every instrument humanity has ever constructed. This is the reality that confronts modern cosmology, and the invisible substance responsible for this cosmic accounting problem is called dark matter, a phenomenon so perplexing that it has become perhaps the deepest mystery in contemporary physics. When astronomers began observing the rotation of galaxies in the 1930s, they noticed something profoundly wrong with their mathematical models, for galaxies were spinning far too quickly to remain bound together by the gravitational force of all their visible stars and gas clouds. Yet they did not tear themselves apart and scatter into space, as physics predicted they should. Rather than accepting that their equations might be incomplete, scientists proposed that galaxies must be surrounded by enormous halos of invisible matter that we cannot directly observe with telescopes, matter that exerts gravitational influence but emits no light, and this hypothetical substance became known as dark matter. The psychological mechanism underlying humanity's acceptance of dark matter stems from our willingness to preserve existing theoretical frameworks even when confronted with contradictory observational evidence. For rather than fundamentally reconsidering the laws of gravity itself, the scientific community collectively agreed that the universe must contain massive quantities of something entirely unknown and unobservable, simply to make the mathematics work. This represents a profound act of intellectual faith, wherein we trust the internal consistency of our models more than we trust the limitations of our instruments, and we assume that the problem lies not with gravity, but with our incomplete census of matter. What makes dark matter truly bizarre is how thoroughly normalized this concept has become despite its essential unknowability. For astronomers now map the distribution of dark matter throughout the cosmos with confidence, They describe its behavior and its role in cosmic evolution. Yet when pressed on what it actually is, the honest answer remains that we genuinely do not know. We have proposed countless candidates from exotic particles to primordial black holes, yet none have been definitively detected or confirmed, and dark matter persists as a placeholder for our ignorance, a mathematical phantom that we have universally accepted as real because the alternative would require us to admit that our understanding of gravity itself might be fundamentally flawed. And this uncertainty has come to feel unremarkable in the landscape of modern physics. Normalized through decades of textbooks and lectures, and research papers that treat dark matter as established fact rather than elaborate conjecture. Imagine standing in a vast, empty room and throwing a ball across it, watching as the ball slows down due to friction and air resistance before eventually coming to rest, which is what we would expect from the fundamental laws of physics that have governed our understanding of motion and force for centuries. Now imagine that instead of slowing down, the ball actually accelerates and speeds up as it travels away from you, moving faster and faster into the distance despite no visible force pushing it, defying every rational expectation you have about how the universe should behave. This is essentially what astronomers observed in the late 1990s when studying distant supernovae explosions throughout the cosmos, discovering that the expansion of the universe itself is not merely continuing, but actually accelerating at an ever-increasing rate, as though some invisible, mysterious force is pushing all matter and galaxies apart from one another with growing intensity. Scientists were forced to confront a deeply troubling reality. Approximately 95% of all the energy and matter in the universe appears to be composed of something that cannot be seen, touched, measured directly, or comprehensively understood through any existing framework of physics, and they collectively named this unknown phenomenon dark energy. The psychological mechanism that allows humanity to accept this profound mystery is rooted in our ability to compartmentalize our ignorance, to acknowledge that science has limits while simultaneously maintaining confidence that these limits will eventually be overcome through future research and technological advancement. We have become remarkably comfortable discussing and theorizing about something we cannot observe, something that leaves no detectable trace in our instruments, something that may not even exist in any conventional sense, and we have built entire mathematical models around this invisible force as though quantifying our confusion somehow diminishes its troubling implications. What persists despite the logical absurdity of the situation is a kind of collective scientific acceptance, a willingness to assign names to mysteries and treat those names as explanations, creating the illusion of understanding when in reality we have simply labeled our profound bewilderment with a sophisticated-sounding term that sounds scientific enough to satisfy our need for rational frameworks. Yet this very act of naming, of creating a conceptual placeholder for our ignorance, has paradoxically proven to be one of science's most productive strategies, enabling physicists to make precise predictions about the universe's future expansion and to design experiments that might eventually pierce the veil of this cosmic mystery, transforming dark energy from an embarrassing admission of failure into a frontier of genuine discovery. Every single night, without fail, your brain enters a state of profound chaos and creativity, conjuring entire worlds, narratives, and scenarios that feel viscerally real while you experience them, yet dissolve into fragments the moment consciousness returns, leaving behind only fleeting impressions and emotional residue that we call dreams, and yet despite centuries of scientific inquiry, we still cannot definitively explain why this happens or what purpose it serves in the grand architecture of human consciousness. When you fall asleep, your brain cycles through different stages of rest, and during the rapid eye movement phase, known as REM sleep, your neural activity surges to levels nearly matching those of wakefulness. Yet simultaneously, the regions responsible for rational thought and memory formation fall silent, creating a biochemical environment where logic becomes optional and the impossible becomes mundane. During these periods, your brain generates elaborate sequences of imagery, emotion, and narrative that feel absolutely real while they unfold, pulling from memories both recent and ancient, from fears you consciously recognize and anxieties you have buried deep, from desires you have never spoken aloud and conflicts your waking mind has not yet processed. The prevailing theories suggest that dreams might serve as a biological filing system, a mechanism by which your brain consolidates memories, processes emotional experiences, and rehearses responses to potential threats in a consequence-free environment where you can confront dangers and social complexities without actual risk. Others propose that dreams represent nothing more than the brain's attempt to create narrative coherence from the random firing of neurons, a phenomenon known as the activation synthesis hypothesis, where your consciousness retroactively weaves meaning into what are essentially neurological accidents. What remains genuinely perplexing is that despite having multiple competing theories, despite our sophisticated neuroimaging technology and advanced understanding of brain chemistry, we cannot point to a single unified explanation that accounts for why consciousness persists during these episodes, why your sense of self remains intact even as logic abandons you, or why you experience emotion so intensely in a state where your body cannot move and your senses receive no external input. We have normalized this nightly descent into controlled hallucination so thoroughly that we barely question it anymore. Yet every person who has ever lived has spent approximately one-third of their life in this strange, altered state, generating thousands upon thousands of narratives that vanish without permanent record, and we continue to accept this profound mystery as simply part of the human condition. Imagine two particles created together in a laboratory, particles so fundamentally linked that they share a quantum state despite being separated by vast distances, perhaps across an entire room or theoretically across the universe itself. And when a scientist measures one particle and observes it spinning in a particular direction, the other particle instantaneously assumes the opposite spin, responding faster than light could possibly travel between them, which fundamentally challenges our intuitive understanding of how information and causality should operate in the physical world. This is quantum entanglement, one of the most experimentally verified yet conceptually disturbing phenomena that modern physics has discovered, a reality that Albert Einstein himself famously called spooky action at a distance, because he found it so philosophically troubling and counterintuitive to everything classical physics had taught us about separation and independence. The mechanism behind this seemingly impossible connection lies in the mathematics of quantum mechanics, where particles do not exist in defined states until they are measured, instead existing in what physicists call a superposition, a simultaneous existence in multiple states at once, and when two particles become entangled, their wave functions become interdependent, meaning that the universe has encoded information that links their outcomes together regardless of the spatial separation between them. What makes this phenomenon so deeply unsettling to our rational minds is that it suggests the universe does not operate on the principle of local realism, the common-sense idea that objects are only influenced by their immediate surroundings and possess definite properties independent of observation. Yet countless experiments since the 1980s have repeatedly confirmed that entanglement is real and that particles do indeed exhibit these instantaneous correlations. Despite having overwhelming experimental evidence supporting quantum entanglement, and despite it being a cornerstone of modern quantum technology, including quantum computers and quantum cryptography, that are actively being developed by major corporations and governments, the phenomenon remains philosophically unresolved in the minds of many scientists and thinkers, who continue to debate whether entanglement represents a true breakdown of locality, a limitation in our understanding of time and causality, or something else entirely that we have yet to conceptualize, and this persistent mystery persists in our collective scientific consciousness, because it forces us to accept that reality operates in ways fundamentally different from our everyday intuitions about how objects and information should behave. Yet perhaps this is the universe's way of reminding us that the deepest truths about reality often lie beyond the reach of our intuitive understanding, and that accepting mystery is sometimes the price of expanding human knowledge. Imagine you are standing in a darkened laboratory where physicists have constructed one of the most elegant and deeply unsettling experiments in the entire history of science, an experiment so strange that even now, more than a century after its initial conception, it continues to perplex and humble our greatest minds. In this laboratory, a beam of light or a stream of electrons is directed toward a barrier with two parallel openings cut into it, two slits positioned side by side, and what happens next defies everything we intuitively understand about how the world should behave. When nobody is watching, when no measurement device is in place to observe which slit the particles pass through, the particles seem to act like waves, passing through both slits simultaneously and interfering with themselves on the other side, creating a pattern of alternating bright and dark bands on a screen behind the barrier. However, the moment you install a detector to catch the particles in the act, to determine definitively which slit each particle actually goes through, the entire behavior changes instantaneously. The particles abandon their wave-like characteristics and instead behave like classical objects, traveling through one slit or the other, never both, and the interference pattern vanishes completely, replaced by two separate bands of impact directly behind each opening. The psychological mechanism at work here seems to involve the very foundation of observation itself, the idea that consciousness or measurement fundamentally alters reality at the quantum level, that the universe exists in a state of indeterminate possibility until something forces it to choose a definite state. We struggle to comprehend how the mere act of looking, of gathering information about a system, can change the outcome of that system so dramatically and instantaneously, creating what appears to be genuine retroactive causality where the future act of measurement influences past behavior. The experiment suggests that reality is not objective and independent, but rather deeply entangled with observation, that particles exist in superposition, existing in multiple states simultaneously, until the wave function collapses due to measurement or conscious observation. We have managed to normalize this profound weirdness by developing sophisticated mathematical frameworks and philosophical interpretations, by speaking of quantum mechanics in technical language and accepting it as simply how the universe operates at subatomic scales, yet the fundamental mystery remains entirely unresolved, untouched by our equations and theories, a silent reminder that consciousness and matter are far more intimately connected than our everyday experience suggests. Perhaps no question has captivated human consciousness quite like the fundamental puzzle of how life itself began on this planet, a mystery that remains stubbornly resistant to complete scientific explanation despite our most sophisticated modern approaches and technologies. We know that approximately 4 billion years ago, Earth was a very different world, a barren landscape of scorched rock and toxic atmosphere, buffeted by cosmic radiation and violent chemical reactions. And yet somewhere within this seemingly inhospitable environment, the first self-replicating molecules emerged and began the long journey that would eventually lead to every living organism we see today. The prevailing scientific hypothesis suggests that life arose through abiogenesis, the process by which non-living chemical compounds gradually organized themselves into increasingly complex structures until they achieved the remarkable property of self-replication, but the precise mechanisms remain frustratingly unclear, shrouded in a fog of uncertainty that grows denser the closer we examine it. We can point to amino acids, those fundamental building blocks of proteins, discovered in meteorites and created in laboratory simulations of early Earth conditions, suggesting that the raw materials were indeed present, yet the leap from chemistry to biology, from inanimate matter to the first living cell, represents a chasm of complexity that our current understanding cannot fully bridge. The spontaneous generation of even the simplest self-replicating molecule under prebiotic conditions seems to require either an improbable concatenation of fortunate circumstances or some organizing principle we have yet to identify. And the transition from chemistry to biology involves a phase change as profound as the difference between a pile of bricks and a functioning cathedral. What persists despite this profound gap in our knowledge is a curious blend of scientific confidence and philosophical humility, an acceptance that somehow, through mechanisms we do not yet fully comprehend, the dead chemicals of early Earth became alive, animated by the same fundamental forces that govern everything else in the universe. Perhaps the most humbling aspect of this inquiry is that life, once established, proved so remarkably resilient and adaptable that it would eventually transform the planet itself, fundamentally altering Earth's atmosphere and geology in ways that made the emergence of consciousness, and our ability to contemplate our own origins, possible at last. Yet in this grand narrative of transformation, we might find not answers but a deeper appreciation for the question itself, for the origin of life may ultimately be less a puzzle waiting to be solved and more a threshold we can only approach asymptotically, forever refining our understanding while acknowledging that some mysteries may preserve their essential unknowability even as science advances. Every night, billions of humans across the planet engage in an act of profound vulnerability, surrendering consciousness for hours at a time without fully understanding why this biological imperative exists in the first place. We spend approximately one-third of our entire lives in a state of unconsciousness, our bodies becoming temporarily paralyzed while our minds enter altered states of consciousness filled with dreams and fragmented narratives that we struggle to remember upon waking. Despite centuries of scientific inquiry and decades of modern neuroscience, the fundamental question of why sleep exists remains frustratingly elusive, clouded by competing theories and incomplete mechanisms that fail to fully account for this universal phenomenon. When we sleep, our brains undergo remarkable transformations, cycling through distinct stages including light sleep and deep sleep and rapid eye movement sleep, during which different neurological processes activate and consolidate and reorganize the information we have accumulated throughout our waking hours. Memory consolidation appears to play a significant role, as our brains work to transfer short-term memories into long-term storage, to organize knowledge, to strengthen neural pathways that are important to us, and to prune away connections that seem less essential. Our bodies experience metabolic shifts during sleep, reducing energy expenditure while simultaneously engaging in cellular maintenance and repair processes, allowing muscles to recover from physical exertion and tissues to regenerate from the constant wear of daily activity. The glymphatic system activates during sleep, flushing toxic proteins and metabolic waste from our brains, a cleaning mechanism that apparently cannot function effectively during waking consciousness, suggesting that sleep serves as a necessary biological detoxification process. Yet despite identifying these functions, neuroscientists cannot definitively explain why we must become completely unconscious to accomplish these tasks, why our brains cannot simply perform these maintenance operations while we remain awake and alert and capable of responding to environmental threats. The evolutionary purpose of sleep remains ambiguous, presenting what researchers call the vulnerability paradox, for sleep leaves us defenseless and immobile precisely when predators and dangers would find us easiest to eliminate, yet the trait persists across virtually every animal species studied, suggesting benefits so profound that they outweigh the existential risks of unconsciousness. We have normalized this daily temporary death so completely that we rarely question its necessity or its mechanisms, accepting sleep as natural and inevitable while remaining fundamentally uncertain about the true biological and neurological imperatives that demand we surrender our consciousness night after night, year after year, for the entire duration of our lives. Imagine a patient suffering from chronic pain walks into a clinic and receives what they believe to be a powerful new medication, yet what they actually receive is nothing more than a sugar pill wrapped in official packaging and delivered with clinical authority. Within hours or days, their pain begins to diminish noticeably, their symptoms ease, and their overall sense of well-being improves measurably, even though the substance they consumed contains no active pharmaceutical ingredients whatsoever. This phenomenon, replicated countless times across the medical field in rigorous controlled studies, represents one of the most perplexing contradictions in modern science, where the mere belief that you are receiving treatment can produce genuine physiological changes in your body that rival the effects of actual medication. The human brain, it seems, possesses the extraordinary capacity to manufacture real chemical and biological responses based entirely on expectation and belief, a capability that researchers have documented in conditions ranging from pain and nausea to blood pressure fluctuations and immune system activation. The mechanism underlying this effect operates through several interconnected pathways that neuroscience is only beginning to map with precision. When a person believes they are receiving genuine treatment, their brain releases neurotransmitters such as dopamine and endorphins, which are the body's own natural painkillers and mood elevators, essentially fooling the nervous system into producing its own pharmacological response. Additionally, the expectation of improvement can reduce stress and anxiety, which themselves suppress immune function and amplify pain perception, creating a cascading biological benefit that compounds over time. What makes this phenomenon particularly bewildering is that it challenges our fundamental understanding of how medicine works, suggesting that the power of belief and expectation can bridge the gap between thought and physical reality in measurable ways. We have somehow normalized and accepted this reality within medical practice, incorporating placebos into clinical trial designs as standard control groups, yet we rarely pause to reflect on how strange and scientifically troubling this truly is. The existence of the placebo effect suggests that consciousness and expectation possess a direct influence over bodily function in ways that our current models of biology cannot fully explain, hinting at deeper connections between mind and matter that science is still struggling to comprehend adequately. In 1954, a physicist named Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when he posed a question that would echo through the decades and fundamentally challenge our understanding of existence itself. If the universe is so vast and so old, containing billions upon billions of galaxies with hundreds of billions of stars in each, and if intelligent life has had roughly 13.8 billion years to evolve and spread across this incomprehensible expanse, then where is everybody? This deceptively simple question has become known as the Fermi Paradox, and it encapsulates one of the most profound mysteries confronting modern science and philosophy. The mathematical logic supporting Fermi's inquiry is nearly irrefutable. When you calculate the sheer probability that Earth is the only planet where life emerged, the numbers become so infinitesimally small that it strains credibility to believe we are alone. Drake's equation, formulated by astronomer Frank Drake in 1961, attempts to estimate the number of communicative civilizations in our galaxy by multiplying variables such as the rate of star formation, the fraction of stars with planets, the number of habitable worlds per star system, and the fraction of those planets where intelligent life develops. Even using conservative estimates for each variable, the results consistently suggest thousands or even millions of potential civilizations should exist merely within our own Milky Way galaxy. Yet when we turn our telescopes to the stars and listen with our most sophisticated radio receivers and detection equipment, we are greeted only by cosmic silence. No signals, no transmissions, no evidence whatsoever of any extraterrestrial intelligence attempting to communicate across the void. This contradiction between the mathematical probability of widespread cosmic life and the absolute absence of any observable evidence, for it represents the fundamental paradox that has fascinated scientists, philosophers, and dreamers for generations. The psychological weight of this mystery lies in how thoroughly it destabilizes our intuitions about probability and our place in the cosmos. We are conditioned by evolutionary history to seek patterns and assume that if something should exist, we would find evidence of it. When that assumption proves false on such a cosmic scale, it creates a profound cognitive dissonance that resists easy resolution. Perhaps life emerges more rarely than we imagine, or perhaps intelligence is even more improbable than we assume. Perhaps the conditions required for complex life are so stringent and so precisely calibrated that Earth represents a genuine rarity in the universe. Or perhaps intelligent civilizations inevitably destroy themselves, either through warfare, environmental collapse, or technological catastrophe, before they ever develop the means to reach across the stars and make contact with one another. Every single day, millions of people around the world lie down on surgical tables, receive an injection or inhale a gas, and then simply cease to exist for a period of time, experiencing nothing, remembering nothing, feeling nothing, and then they wake up hours later with their bodies fundamentally altered by procedures they were completely unconscious for. Yet modern medicine still cannot fully explain the actual mechanism by which anesthesia accomplishes this remarkable feat of rendering human consciousness temporarily offline. When you receive general anesthesia before surgery, whether it's propofol administered intravenously or sevoflurane inhaled through a mask, your brain chemistry is disrupted in a way that causes you to lose consciousness, lose the ability to feel pain, lose muscle tone, and lose all memory formation. Yet scientists studying this phenomenon have discovered something profoundly unsettling. They have no unified theory explaining how or why this actually happens at the molecular level. Researchers know that anesthetic drugs interact with ion channels and neurotransmitter receptors in the brain, affecting how neurons communicate with each other, but the specific cascade of events that transforms a conscious, aware human being into an unconscious body that continues to breathe and maintain vital functions remains largely mysterious, suggesting that our understanding of consciousness itself may be incomplete. What makes this situation particularly strange is that we have normalized it entirely, treating anesthesia as just another routine medical tool, despite the fact that we are essentially inducing a controlled coma in patients without truly understanding the mechanism. And then we rely on monitors and experience to ensure they wake up again, trusting in a process we cannot fully explain. The history of anesthesia reveals this uncertainty too, as surgeons began using ether and chloroform in the 1800s with tremendous success. Yet they had no idea whatsoever why these chemicals worked. They simply observed that they did, and for over 170 years since then, despite incredible advances in neuroscience and molecular biology. We still lack a complete mechanistic explanation for why pushing certain molecules into your bloodstream makes you forget the next several hours of your life. Anesthesiologists will tell you they understand how to use anesthesia safely and effectively, and they do, but if you press them on the fundamental question of why consciousness disappears and returns when we expose the brain to these compounds, they will admit that mystery remains at the heart of their specialty, making every surgical procedure a remarkable act of faith in a process that works beautifully in practice, but remains theoretically unexplained in principle. Imagine standing near a window during a severe thunderstorm, watching the sky light up with brilliant flashes of lightning, when suddenly you notice something that defies everything you thought you understood about electrical phenomena in the atmosphere. A glowing sphere of light, somewhere between the size of a grapefruit and a beach ball, floats silently through the air, hovering just above the ground or drifting slowly through the clouds with an almost purposeful elegance. This is ball lightning, one of the most perplexing and poorly understood phenomena that science has encountered, documented by thousands of reliable witnesses throughout human history, yet remaining stubbornly resistant to explanation or laboratory reproduction. The sphere often appears to have a color ranging from brilliant white to yellowish orange, sometimes with hints of red or blue at its edges, and it moves with a peculiar independence from the surrounding air currents, as if governed by forces entirely unknown to modern physics. Observers have reported that ball lightning passes through solid objects without apparent damage, glides silently across landscapes at ground level, and occasionally enters buildings through walls or windows before vanishing with sudden explosions or simply dissolving into nothingness. The phenomenon typically lasts between a few seconds and several minutes, though some accounts stretch far longer, leaving witnesses absolutely convinced of what they have witnessed despite the universal skepticism of the scientific community. Scientists have proposed countless theories to explain ball lightning. Plasma filaments, chemical reactions in the air, exotic states of matter, magnetic confinement, silicon oxidation, or microwave radiation trapped in ionized air. Yet none of these explanations have achieved widespread acceptance or been successfully replicated under controlled laboratory conditions. What makes ball lightning particularly frustrating for researchers is that it appears to violate fundamental principles of physics, maintaining its cohesion and energy far longer than theoretical models would permit, suggesting that either our understanding of atmospheric electrical phenomena remains fundamentally incomplete or that something else entirely is occurring. Despite decades of scientific investigation and technological advancement, despite thousands of eyewitness accounts from credible observers including pilots, meteorologists, and military personnel, ball lightning persists as a genuine mystery, hovering at the intersection between the documented and the inexplicable. The most intriguing aspect of ball lightning research lies in the tantalizing possibility that future technology may finally reveal the mechanisms behind this phenomenon, transforming one of nature's last great atmospheric mysteries into comprehensible science, and perhaps in doing so, unlock entirely new understanding of plasma physics and energy behavior that could reshape our technological capabilities. On August 15, 1977, a radio astronomer named Jerry Amon was sitting at the Big Ear Radio Telescope facility in Ohio when something extraordinary happened, something that would remain unexplained for decades and continue to baffle the scientific community even today. While monitoring frequency 81.5 MHz for signs of extraterrestrial intelligence as part of the ongoing SETI project, Amon noticed an unusually strong and narrow-band signal emanating from a region of space near the Chi Sagittarii star group, and the signal was so remarkable that he circled it on the computer printout and wrote the word "wow" next to it in red pen, a reaction of pure astonishment that would give this cosmic mystery its enduring name. The signal lasted for exactly 72 seconds, displayed characteristics that suggested it was not terrestrial interference or a natural astronomical phenomenon, appeared to come from a specific point in the cosmos rather than scattered across the sky, and bore the hallmarks of what scientists believed an artificial transmission from another civilization might resemble. Yet when researchers attempted to locate it again in subsequent nights and weeks and months, the signal never returned, vanishing as mysteriously as it had arrived and leaving behind only this single, tantalizing data point that refused to fit into any established scientific category. The psychological mechanism that allows the wow signal to maintain its grip on our imagination, despite more than 4 decades of non-confirmation, stems from the profound human longing to find definitive proof that we are not alone in the universe. A desire so deeply embedded in our consciousness that a single ambiguous piece of data becomes amplified and transformed into something far more meaningful than the evidence might ordinarily warrant. We have normalized the mystery of the wow signal by accepting that it remains unsolved, by allowing speculation and theory to fill the void left by concrete answers, and by treating this 47-year absence of repetition not as evidence against its extraterrestrial origin, but merely as proof of how rare and precious such signals must be, how infinitesimally small the window of opportunity might be to detect them, and how our brief moment of potential contact with an intelligent civilization perhaps passed us by through sheer cosmic chance. The wow signal persists in our cultural consciousness as a monument to unanswered questions, a reminder that vast regions of reality remain beyond our comprehension, and a symbol of how desperately we search the heavens for confirmation of something we can feel but never quite grasp. Consider the simple act of pouring a cup of tea and watching it cool on a table. The hot liquid gradually loses its heat to the surrounding air, becoming tepid, then cold, and it never reverses this process. The cup never spontaneously grows hot again without an external energy source. This is the arrow of time, the seemingly obvious fact that events flow in one direction, from past to future, never backward. We experience this asymmetry constantly in our daily lives, watching ice melt, but never watching water spontaneously freeze into perfect cubes, observing eggs crack and scramble, but never witnessing scrambled eggs assembling themselves back into whole, unbroken eggs, witnessing people age from birth to death, but never aging backward toward infancy. Yet here is where physics becomes genuinely unsettling. The fundamental laws of physics at the microscopic level are completely reversible. The equations that govern the motion of atoms and particles work equally well whether time moves forward or backward. There is nothing in the basic mathematics of physics that demands time should flow in one direction rather than another. The arrow of time emerges from entropy, a measure of disorder and randomness in a system, and the second law of thermodynamics, which states that entropy always increases in an isolated system. This law exists not because the universe is inherently designed to move forward, but because there are simply far more disordered arrangements of matter and energy than ordered ones. A room filled with air molecules is vastly more likely to remain that way than for all molecules to spontaneously gather in one corner, and this probability overwhelms all other possibilities. Yet this explanation, while mathematically sound, cannot fully account for why we remember the past and not the future, why consciousness itself seems bound to experience time moving forward, why the universe began in an extremely ordered state and has been expanding ever since. The arrow of time remains one of science's deepest mysteries, a feature of reality so fundamental and seemingly so obvious that we rarely question it, even though our most sophisticated understanding of the universe cannot fully explain why it exists at all. Perhaps this is why the arrow of time feels so intimate to us. It is not merely a physical principle, but the very structure through which we exist, the invisible current that carries us from birth toward death, from ignorance toward memory, making the mystery of time's direction ultimately inseparable from the mystery of what it means to be conscious at all. Perhaps this is why physicists and philosophers continue to grapple with time's direction not as a mere technical problem to be solved, but as a question that touches something essential about existence itself. For in understanding why time flows only forward, we may be uncovering clues about the deepest nature of reality and our place within it. Deep within the biological architecture of countless creatures across our planet exists a sensory capability that remains fundamentally mysterious to modern science, a perceptual mechanism so strange and so elegantly functional that we are only beginning to understand its basic operational parameters. This phenomenon is known as magnetoreception, and it represents one of the most profound unknowns in animal biology, a sixth sense of sorts that allows birds to navigate thousands of miles across continents and oceans, that guides sea turtles from the moment of their hatching back to the exact beaches where they were born, and that enables migratory whales and dolphins to traverse the vast expanses of open ocean with uncanny precision. What makes this sensory ability so bewildering is not merely that animals possess it, but rather that scientists still cannot definitively explain the precise mechanisms by which this navigation occurs, despite decades of intensive research and increasingly sophisticated laboratory investigations. Researchers have identified certain proteins in animal cells, particularly iron oxide compounds and magnetite crystals that accumulate in specialized tissues, and they have proposed theoretical frameworks involving quantum mechanical effects and electromagnetic field interactions with specialized neural pathways. Yet none of these explanations provides a complete and satisfactory account of how a bird brain translates the Earth's magnetic field into directional information with such astounding accuracy. The evidence itself is undeniable and reproducible. When researchers expose migratory birds to artificial magnetic fields rotated at slight angles, the birds adjust their flight direction accordingly, responding to changes that are imperceptible to human instruments without technological assistance, suggesting that these animals are detecting something real and quantifiable about the world's electromagnetic properties. Yet somehow, despite this observable reality, and despite knowing that magnetoreception must involve physical processes governed by the laws of nature, the complete neural and molecular story remains fragmented and incomplete, with crucial gaps in our understanding persisting as if some essential piece of the puzzle continues to elude our scientific grasp. We have come to simply accept this as routine biological fact, cataloging it in textbooks and museum exhibits, normalizing the absolutely extraordinary notion that life itself has evolved sensory organs and neural systems for perceiving invisible force fields that surround our entire planet, a capability that seems to blur the boundary between what we consider possible and impossible in the natural world. Imagine filling two identical containers with water, one with hot water and one with cold water, and placing them both in a freezer at the same temperature, watching them both slowly transform from liquid to solid state, and then observing something that should be scientifically impossible occurring right before your eyes. The hot water freezes faster than the cold water, defying every fundamental principle of thermodynamics that we have come to understand and accept as absolute truth in our modern scientific framework. This phenomenon, first documented by Aristotle over 2,000 years ago and later formally observed and named after Mpemba, a Tanzanian student who rediscovered it in 1963, remains one of the most persistently puzzling anomalies in the natural world. A situation where hot water somehow manages to release its thermal energy more efficiently and reach the solid state before its cooler counterpart should logically be able to do so. The mechanism behind this effect has been theorized and debated extensively within the scientific community, with researchers proposing several interconnected explanations that might account for this counterintuitive behavior, including the possibility that convection currents in the warmer water distribute heat more effectively throughout the container, that evaporation from the surface of hot water removes more mass and therefore requires less energy to fully freeze, that the dissolving and escape of dissolved gases from hot water reduces the thermal capacity of the liquid, or that there are subtle differences in the crystalline structure formation between water that has been heated and water that has not. Yet despite decades of rigorous experimentation and theoretical consideration, no single explanation has achieved universal acceptance among physicists and chemists, and the effect itself remains inconsistently reproducible depending on the specific conditions of the experiment, the containers used, the initial temperatures, and countless other variables that seem to determine whether the phenomenon will manifest or simply disappear into the background noise of ordinary freezing behavior. What makes this particularly fascinating is how the Mpemba effect has become normalized within scientific discourse not as a solved mystery, but as an accepted paradox, something that researchers acknowledge exists in certain circumstances, while simultaneously admitting they cannot definitively explain why, a state of knowledge that persists in our supposedly advanced understanding of physical law, reminding us that even the most fundamental substances and processes in our world maintain secrets that continue to elude our comprehension. Perhaps this unresolved mystery serves as a humbling reminder that nature's complexities often outpace our explanatory frameworks, and that the most ordinary substances, like water itself, can harbor profound secrets waiting beneath their familiar surfaces. Imagine yourself sitting in a coffee shop you have never visited before, watching a barista pour steamed milk into a ceramic cup while a stranger beside you laughs at something on their phone. And suddenly, without warning, your mind floods with an overwhelming sensation that you have experienced this exact moment before, that you have sat in this precise chair, heard this precise sound, seen this precise angle of sunlight crossing the counter. And yet you know with absolute certainty that this is impossible because you have never been here in your life, and the feeling persists for several seconds before dissolving into confusion and a lingering unease that you cannot quite shake. This is déjà vu, a French term meaning already seen, and it represents one of the most widespread yet profoundly unexplained phenomena of human consciousness, affecting approximately 60 to 80% of people at least once in their lifetime, with some individuals experiencing it multiple times monthly. The mechanism behind déjà vu remains stubbornly resistant to complete scientific explanation despite decades of rigorous neurological research and psychological investigation, though several competing theories have emerged from laboratories and clinical settings around the world. One prevailing hypothesis suggests that déjà vu results from a temporary glitch in memory processing, where sensory information enters the neural systems responsible for long-term memory retrieval simultaneously with the systems processing immediate perception, creating a false sense of familiarity where the brain mistakenly signals that a novel experience has been encountered before. Another theory proposes that déjà vu emerges from a brief interruption in attention wherein a scene or situation is perceived, and then immediately reperceived microseconds later after an attentional lapse, causing the brain to interpret the second perception as a memory of the first, generating that distinctive feeling of repetition and recognition. Yet another framework suggests that we all accumulate vast networks of implicit memories throughout our lives, fragmentary and abstract patterns of experience stored outside conscious awareness. And déjà vu may occur when a present situation activates enough of these implicit memory networks that our minds generate a strong sense of familiarity, even though no explicit memory can be retrieved, leaving us with the paradoxical feeling of knowing without knowing. Despite these explanations, the phenomenon persists in its essential mystery, because none of these theories fully accounts for why certain people experience déjà vu more frequently than others, why some individuals report never experiencing it at all, or why the sensation carries such distinctive emotional weight despite being demonstrably false and rooted in neural misfiring rather than any genuine recognition of repeated time. Imagine a region of space so dense, so infinitely compressed, that nothing, not even light itself, can escape its gravitational pull once it crosses a certain boundary called the event horizon. This is a black hole, one of the most mysterious objects in the universe, and it presents science with a problem so profound that physicists have spent decades wrestling with its implications. The paradox known as the black hole information paradox emerges from a fundamental conflict between two of the most successful theories in modern physics: general relativity and quantum mechanics. According to general relativity, when matter falls into a black hole, it is lost forever, crushed into an infinitely dense point called a singularity where all the information that once defined it, its composition, its structure, its history, is obliterated from the universe. Yet quantum mechanics insists that information can never truly be destroyed. It can only be transformed, scrambled, or encoded in ways we might not immediately recognize. This creates an impossible situation where the laws of physics seem to contradict themselves at the most fundamental level. In 1974, physicist Stephen Hawking discovered that black holes are not entirely black. They emit radiation due to quantum effects near the event horizon, causing them to slowly evaporate over unimaginably long timescales. This discovery deepened the paradox because it suggested that eventually a black hole would completely disappear, taking all the information it consumed with it into absolute nothingness. If this were true, then information really could be destroyed in the universe, violating a core principle of quantum mechanics. For decades, this contradiction has persisted despite being no logical reason it should remain unresolved given the ingenuity of modern theoretical physics. Scientists have proposed numerous solutions, from the holographic principle suggesting that three-dimensional information is encoded on a two-dimensional surface, to the idea that information is somehow preserved in subtle correlations within the radiation itself, yet none have achieved universal acceptance. We have normalized this paradox as simply another frontier of human understanding, a puzzle that future theories might solve, a reminder that our grasp of reality remains fundamentally incomplete in ways we are only beginning to comprehend. Perhaps most intriguingly, the resolution of this paradox may require us to fundamentally rethink what we mean by information itself, suggesting that the universe operates according to principles so alien to our intuition that even our most abstract theories are merely shadows of a deeper reality we have yet to glimpse. What if the universe itself is fundamentally a processor of information, and black holes are not exceptions to this rule, but rather its most extreme expression? Cosmic engines that don't destroy information, but compress it beyond our current ability to perceive or measure it. In the beginning, according to our most fundamental understanding of physics, the Big Bang should have created equal amounts of matter and antimatter, two opposite forms of substance that annihilate each other completely when they come into contact, releasing pure energy in the process. Yet here we stand, in a universe composed almost entirely of matter, surrounded by galaxies, stars, and planets made from the very stuff that should have been neutralized in those first fractions of a second after creation. This is the matter-antimatter asymmetry, one of the deepest mysteries in modern physics, a puzzle so profound that it challenges our understanding of why anything exists at all. Scientists have searched for decades through particle accelerators and observational data, trying to understand why the universe did not simply annihilate itself into radiation and light in those first infinitesimal moments of cosmic history. The mechanisms we have discovered so far, such as charge parity time violation, provide only a partial explanation, accounting for perhaps 1 part in a billion of the observed imbalance, leaving the vast majority of this cosmic mystery completely unexplained. We have built our entire scientific worldview on the principle of symmetry, on the assumption that nature operates according to balanced laws that should produce equal outcomes from opposite initial conditions. Yet the universe has violated this expectation in the most catastrophic way imaginable, creating an existence that should never have been possible according to our equations. What makes this asymmetry so profoundly unsettling is not merely that we cannot explain it, but that its existence is precisely what allows us to exist at all, meaning that the very condition we find most inexplicable is the one prerequisite for our own emergence from the void. We accept this fundamental imbalance as simply the way things are, integrating it into our models and theories as though it were a given fact rather than an indicator of something deeply wrong with our current understanding of reality itself. Perhaps the most humbling possibility is that this asymmetry points toward physics beyond our current standard model, hidden symmetries, undiscovered particles, or mechanisms operating at energy scales we have yet to reach, reminding us that our equations, for all their elegance and predictive power, may capture only a fraction of nature's true complexity. The search for this missing physics has already begun in experiments like those at the Large Hadron Collider, where physicists meticulously study the subtle differences between how matter and antimatter behave, hoping that somewhere in those minute deviations lies the key to understanding why the universe chose existence over oblivion. Until we uncover the true source of this asymmetry, we remain inhabitants of a cosmos whose most fundamental property, the very fact that it contains anything at all, rests upon a mystery we have yet to solve. In the remote and desolate landscape of Death Valley in California, specifically within a dried lakebed known as the Racetrack Playa, an extraordinary phenomenon has puzzled scientists and observers for nearly a century, leaving behind a trail of questions that seem to defy the most basic principles of physics and motion that we have come to accept as universal truth. Large rocks, some weighing as much as 700 pounds, appear to move across the completely barren and flat expanse of cracked earth entirely on their own, leaving long trails of disturbed sediment and dust behind them as evidence of their mysterious journeys. Yet no one has ever actually witnessed these stones in the act of moving, and for decades the mechanism behind this motion remained utterly inexplicable. The rocks themselves vary in size from small pebbles to massive boulders, and they seem to travel in different directions and at different speeds, creating an intricate pattern of crisscrossing tracks that suggest they are being guided by some invisible force. Yet the dried lakebed itself shows no signs of slopes or water that would provide any obvious explanation for the movement. Scientists and curious visitors have proposed countless theories over the years, ranging from magnetic forces to extraterrestrial intervention, and the sheer impossibility of explaining these movements through conventional means created a sense of wonder and mystery that seemed to validate the idea that some phenomena on our world simply could not be understood through rational scientific inquiry. However, what made the sailing stones particularly fascinating was not just their movement, but rather the psychological investment that humans developed in maintaining their mystery, as people seemed almost reluctant to accept mundane explanations when they were finally proposed through careful observation and experimentation. In more recent years, researchers have demonstrated that during rare periods of rain followed by rapid freezing, thin sheets of ice can form across the playa, and when heated by the sun, these ice sheets can crack and shift, providing just enough force to move the rocks across the slick surface, particularly when combined with wind that acts upon any protruding surface of the stone. And yet, despite this explanation being scientifically validated and experimentally demonstrated, the sailing stones have retained their reputation as mysterious and unexplained phenomena in popular culture and imagination. The persistence of this mystery, despite having a rational explanation, reveals something profound about human nature itself, suggesting that we are somehow reluctant to fully accept the ordinary explanations for extraordinary observations, and we continue to speak of sailing stones with the same sense of wonder as we did when they were truly inexplicable. Imagine waking in the dead of night with a sudden, jarring awareness of your own consciousness, yet finding yourself completely unable to move your body. Your eyes might flutter open or remain in darkness, but your limbs refuse to respond to even the most desperate mental commands, as though some invisible force has pinned you to the mattress with tremendous weight. This is sleep paralysis, a phenomenon that strikes somewhere between 5 and 40% of the global population at least once in their lifetime, and for some, it becomes a recurring nightmare that repeats night after night with nauseating regularity. During these episodes, people often report not only the inability to move, but also an overwhelming sense of dread, a crushing pressure on the chest that makes breathing feel labored, and in many cases, the presence of a shadowy figure standing over them or a dark entity perched upon their body, malevolent and absolutely real in every sensory way. The experience typically lasts only seconds to a few minutes, yet to the person experiencing it, time stretches into an eternity of helplessness and primal fear. The scientific explanation for this phenomenon is actually quite straightforward and thoroughly documented by neuroscientists and sleep researchers who have studied it extensively for decades. During rapid eye movement sleep, the stage where dreams occur, your brain essentially paralyzes your voluntary muscles as a protective mechanism to prevent you from acting out your dreams and flailing about in bed or potentially hurling yourself through a window during a nightmare. This state is called muscle atonia, and it is a perfectly normal and necessary part of the sleep cycle in all mammals. However, what happens during sleep paralysis is a profound dissociation between consciousness and the paralysis mechanism, where your mind suddenly awakens and gains awareness while your body remains locked in the muscle atonia of REM sleep, creating a bizarre and terrifying discord between awareness and agency. The hallucinations that accompany sleep paralysis arise because your brain is still partially in dream mode, still generating the vivid imagery and emotional intensity of dreams, even as your conscious mind recognizes the bedroom environment around you, leading to a horrifying blend of dream content overlaid upon waking reality. The shadowy figures and demonic presences that so many people report seeing are likely the result of your brain's pattern recognition systems misfiring in this confused state, interpreting shadows, furniture, or the edge of your own vision as threatening humanoid shapes, a phenomenon researchers call threat simulation. In the small town of Taos, New Mexico, nestled in the high desert where the landscape stretches endlessly beneath an expansive sky, residents have reported a phenomenon so persistent and so inexplicable that it has bewildered scientists, acousticians, and skeptics for decades. It is a low-frequency humming sound, described as a subtle but unmistakable vibration in the air, a droning noise that some hear as a constant companion in their everyday lives, while others remain completely oblivious to its presence. The hum began appearing in the early 1990s, with accounts suggesting it was first noticed by a handful of individuals before spreading through the community like a shared hallucination, though one rooted in something undeniably real. People described it variously as the sound of a distant diesel engine, or perhaps a large electrical transformer in operation, or even the resonance of the earth itself humming beneath their homes. The frequencies measured by researchers typically fell between 17 and 50 Hz, right at the threshold of human hearing, and the sound seemed to pulse and vary depending on the observer's location, time of day, and even their emotional state. Some residents reported it keeping them awake at night, while others found it merely an ambient oddity, something present but not particularly troubling. Scientists dispatched to investigate the phenomenon found themselves reaching dead ends, unable to locate a single definitive source despite their most sophisticated acoustic equipment and methodologies. The psychological mechanism underlying the Taos Hum involves a complex interplay between genuine low-frequency acoustic phenomena, the power of suggestion, and the human brain's remarkable ability to create meaningful patterns from environmental noise. Once word spread that mysterious humming sounds were occurring in Taos, the power of expectation began shaping perception itself, with newly aware residents beginning to listen deliberately for something they had previously ignored entirely. This creates a self-reinforcing cycle where attention amplifies sensation, and attention itself becomes evidence of the phenomenon's reality. The brain possesses an extraordinary capacity to isolate specific frequencies from the background noise of daily existence, much like how a parent can hear their child's cry amid a crowded room while filtering out everything else. Additionally, low-frequency sounds that exist below the threshold of conscious hearing can still be perceived by the body as vibrations, felt rather than heard, creating an ambiguous sensory experience that the mind struggles to categorize. In many cases, residents may have been picking up on genuine industrial noise, electrical infrastructure, or even natural geological rumbling that had always been present but had gone unnoticed until collective attention drew focus toward it. When you place your hand upon a cat's warm body and feel that unmistakable vibration emanating from deep within its chest, you are experiencing one of the most common yet profoundly mysterious phenomena in the animal kingdom, a sensation so familiar that we have given it a name that mimics its very sound. Yet the actual mechanisms and true purposes behind this behavior remain shrouded in scientific uncertainty and contradiction. The purring of a cat occurs at a frequency typically ranging between 25 and 150 Hz, a rhythmic vibration produced by rapid contractions of the laryngeal muscles and the diaphragm, creating a sound that humans have long associated with contentment and comfort, the stereotypical indicator of a pleased and satisfied feline companion resting peacefully in your lap. Yet despite centuries of observation and decades of scientific investigation, researchers remain fundamentally uncertain about why cats evolved this behavior in the first place, what primary purpose it serves in their biological existence, or whether our common understanding of purring as merely a sign of happiness represents the complete picture of its significance. The prevailing theory suggests that purring functions as a self-soothing mechanism, that cats produce this vibration to calm themselves during moments of stress, illness, or injury, a hypothesis supported by observations of cats purring while in pain or undergoing surgical procedures, suggesting that the behavior serves an internal regulatory function rather than simply communicating emotional states to external observers. Additionally, mother cats purr to their kittens during nursing, and kittens purr back, indicating some form of bonding or communication mechanism that operates on a frequency that humans can perceive but do not fully comprehend. Some researchers have theorized that the low-frequency vibrations of purring might actually promote bone healing and muscle development, though this remains largely speculative and lacks conclusive scientific validation. The remarkable aspect of this phenomenon is that despite living with cats for thousands of years, despite the countless hours humans have spent studying feline behavior, and despite our advanced technological capabilities for analyzing animal communication, we continue to accept purring as this charming, somewhat understood mystery, never quite demanding the rigorous scientific explanation that we might require for understanding similar behaviors in other species. Allowing this ancient puzzle to persist in our collective consciousness as both a mundane daily occurrence and an enduring enigma. Perhaps this acceptance of mystery reflects something deeper about our relationship with cats themselves, creatures that have chosen to live alongside us while maintaining an essential inscrutability, allowing us to experience their purring as both a gift we receive and a secret we are not entirely meant to solve. Deep within the cosmos, astronomers have stumbled upon a profound discrepancy that challenges everything we thought we understood about the universe's expansion, and this mystery is called the Hubble tension, a measurement contradiction that has persisted for years despite our most sophisticated instruments and calculations. The Hubble constant, named after astronomer Edwin Hubble, represents the rate at which the universe is expanding, and it is one of the most fundamental numbers in cosmology, determining how fast galaxies are moving away from us, and by extension, the age and ultimate fate of the universe itself. However, when scientists measure this value using different methods, they consistently arrive at different answers, and these answers are incompatible with one another, creating a genuine puzzle that sits at the foundation of modern physics. The first measurement method involves observing distant supernovae, those brilliant stellar explosions that serve as cosmic distance markers, and by measuring how bright they appear and how far away they are, researchers calculate the Hubble constant to be approximately 67 kilometers per second per megaparsec. The second method, however, relies on observations from the cosmic microwave background, the ancient radiation left over from the Big Bang itself, and when physicists analyze this data, they arrive at a value of approximately 73 kilometers per second per megaparsec, a difference that seems small until you realize that this measurement discrepancy has no obvious explanation within our current understanding of physics. The tension between these measurements suggests that either one of the observational methods contains a systematic error, or perhaps something fundamental about our comprehension of the universe itself remains incomplete and hidden from our current frameworks. What makes this mystery particularly compelling is that despite years of scrutiny, cross-checking, and refinement, the discrepancy has not resolved itself, but instead has become more statistically significant and more troubling to physicists worldwide. The persistence of this anomaly has led some to speculate that unknown forms of matter or energy might be influencing the measurements, while others propose that the early universe might have behaved differently than our models suggest, and still others wonder whether entire revisions to general relativity might be necessary. Yet despite the profound implications, despite conferences dedicated to this problem, and despite the investment of considerable resources in solving it, we continue to live with this inexplicable tension, accepting the mystery as part of the landscape of modern science, a testament to how much remains unknown even in our most measured and precise observations of reality. Approximately 540 million years ago, during a geological period known as the Cambrian, something extraordinary occurred in Earth's oceans that fundamentally transformed the trajectory of all life on this planet, and it happened with a speed that confounds our understanding of evolutionary processes. For nearly 3 billion years before this moment, life on Earth consisted almost entirely of simple, single-celled organisms and soft-bodied creatures that left barely a trace in the fossil record. Yet within a relatively brief window of geological time, spanning perhaps only 20 to 25 million years, the vast majority of major animal groups suddenly appeared in the rocks, with little to no apparent ancestral forms linking them to what came before. Trilobites emerged with their sophisticated compound eyes and segmented bodies already fully formed, while arthropods of bewildering complexity, creatures like Anomalocaris with its grasping appendages and circular mouth, appeared seemingly without intermediate steps, alongside strange filter feeders, predators, and organisms so bizarre that they defy easy classification even by modern zoological standards. The conventional explanation rests upon the principle that evolution requires time, countless generations of small mutations and natural selection gradually refining organisms across vast stretches of years. Yet this event appears to compress what should require hundreds of millions of years of incremental change into a period that, while long in human terms, seems almost instantaneous when measured against the deeper history of life itself. Scientists have proposed various mechanisms to explain this phenomenon, including the idea that genetic toolkits for building body plans evolved during the Ediacaran period before the Cambrian, and that once these fundamental developmental programs were in place, they could be rapidly shuffled and recombined to produce novel forms, or that environmental changes such as increased oxygen levels in the oceans, or perhaps the evolution of predation itself, created an arms race that rapidly diversified body plans and survival strategies. Yet despite these sophisticated explanations, the Cambrian explosion retains an element of genuine mystery that sits uncomfortably within our frameworks of understanding, because the fossil record does not show the gradual transitions we would expect. The intermediate forms remain elusive. And the sheer diversity and complexity of life that emerged during this period seems to require explanatory mechanisms that we have not entirely reconciled with our current understanding of how evolution actually proceeds at measurable scales. Imagine a small glass flask filled with water, sitting in complete darkness, and then imagine striking that water with sound waves so intense and precisely calibrated that they create microscopic bubbles that collapse with such violent force that they emit actual light. This is sonoluminescence, a phenomenon where acoustic energy transforms into visible photons through a mechanism so counterintuitive that it exists at the boundary between the understood and the inexplicable. When high-frequency sound waves, typically ultrasound operating at frequencies far beyond human hearing, pass through a liquid medium, they create regions of extreme pressure differential, generating tiny cavitation bubbles that form and then implode with temperatures reaching thousands of degrees Kelvin, briefly becoming hotter than the surface of the sun itself. Hot enough to strip electrons from atoms and produce flashes of blue light that can be observed in a darkened laboratory. The process seems almost alchemical in nature, converting acoustic vibrations into electromagnetic radiation, and when a single bubble is trapped and made to oscillate repeatedly through this cycle, it produces a consistent pulse of light with each collapse, becoming what scientists call a sonoluminescing bubble, a miniature pulsating star generated entirely through controlled sound waves in a glass container. The psychological difficulty in accepting this phenomenon lies in our deep-seated categorical separation between sound and light as fundamentally different phenomena, belonging to different domains of physics, governed by different equations, and existing in different parts of the electromagnetic spectrum. So to watch sound literally become light feels like witnessing a breach in the rules that govern reality itself. The mechanism behind this transformation is thought to involve extreme temperatures ionizing the gas within the collapsing bubble, creating plasma that radiates light, yet despite decades of study and increasingly sophisticated equipment, scientists cannot explain all aspects of sonoluminescence with complete certainty, particularly why the light produced sometimes exceeds theoretical predictions, and why the phenomenon is so remarkably inefficient despite its violent nature. What makes this phenomenon especially unsettling is how casually it sits in modern science, used in practical applications and studied in laboratories worldwide, yet never truly demystified, never given a complete and satisfying explanation that accounts for all observed variables. Consider for a moment the tardigrade, a microscopic animal so impossibly resilient that it challenges our fundamental understanding of what life requires to persist. These creatures, barely visible to the naked eye at half a millimeter in length, possess an almost supernatural capacity to survive conditions that would instantaneously obliterate nearly every other organism on Earth. They have been exposed to the vacuum of outer space, subjected to radiation doses thousands of times higher than lethal human levels, frozen to near absolute zero temperatures where all molecular motion nearly ceases, and desiccated to the point where they contain virtually no water whatsoever. Yet they enter a state called cryptobiosis and emerge unharmed when conditions improve. Scientists have sent them into orbit aboard spacecraft, ejected them into the radiation-soaked environment beyond any protective atmosphere, and retrieved them alive, their biological systems somehow remaining intact despite exposures that seem to defy every principle of chemistry and physics we believe governs living matter. The mechanisms behind this extraordinary survival are only partially understood even by modern biology, leaving us with an unsettling recognition that life itself can operate according to rules far stranger than our models predict. We have normalized this knowledge by compartmentalizing it into academic literature and scientific journals, treating the tardigrade as merely another interesting curiosity in an endless catalog of biological phenomena rather than confronting what it truly represents. A living demonstration that the boundaries we have drawn around life's requirements and vulnerabilities may be far more permeable and uncertain than we ever imagined possible. If tardigrades can persist in conditions we deemed absolutely incompatible with life itself, then we must ask what other assumptions about biology's constraints might prove equally fragile under scrutiny, and whether the universe's capacity to generate and sustain life might be far more abundant and resilient than our limited terrestrial experience has led us to believe. Perhaps this is why the discovery of tardigrades has subtly shifted the philosophical ground beneath astrobiology itself. If Earth's most extreme environment dwellers can thrive in the conditions of space, then the search for life beyond our planet need not be confined to worlds that mirror our own temperate oceans and atmospheres. The tardigrade stands as a quiet reminder that our conception of habitability has been parochially narrow, measured against the comfort zones of familiar organisms rather than against the actual outer limits of what biology can endure. In this light, the tardigrade becomes not merely a biological oddity, but a cosmic messenger, evidence that life's signature in the universe may be written in an alphabet far more complex and forgiving than we have yet learned to read. On May 1, 1997, underwater hydrophone arrays operated by the National Oceanic and Atmospheric Administration detected an extraordinarily loud, low-frequency sound traveling through the Pacific Ocean at a distance of approximately 5,000 kilometers from the nearest research vessel, making it one of the most powerful underwater acoustic events ever recorded in human history. The sound lasted nearly 2 minutes and possessed characteristics that were entirely unlike anything previously documented in marine science, exhibiting a frequency range that suggested it could only have been produced by something of truly massive biological proportions. Yet no known animal on Earth possessed the vocal apparatus or physiological capacity to generate such an enormous acoustic event. The mysterious phenomenon became known as the Bloop, and it captured the imagination of oceanographers, marine biologists, and the general public with equal intensity, spawning decades of speculation, theoretical frameworks, and cultural fascination that would persist long after the scientific community had largely moved toward more conventional explanations. The psychological mechanism underlying our obsession with the Bloop stems from the fundamental human need to identify and categorize unknown phenomena, combined with the deep uncertainty that surrounds our actual knowledge of Earth's oceans, which remain far less explored than the surface of the Moon. When confronted with genuine mystery, the human mind generates narrative templates automatically, filling gaps with plausibility and internal consistency. And in this case, the Bloop existed in that perfect liminal space where it could theoretically represent an undiscovered megafauna, an unknown cetacean species of impossible size, or something that challenged our entire taxonomic understanding of marine life. The sound became a cultural mirror, reflecting our anxieties about what remains hidden in unexplored depths, our simultaneous desire to believe in genuine mystery alongside our increasing scientific comfort with explanation and categorization. Despite technological advances and continued acoustic monitoring, the Bloop has largely faded from scientific discussion, having been attributed by most researchers to ice-calving events or other non-biological phenomena. Yet the mystery persists in popular culture and continues to generate engagement precisely because the explanation remains somewhat unsatisfying and incomplete. We have normalized the Bloop's existence not as a solved problem, but as a quaint reminder of a moment when the unknown still seemed genuinely unknowable, and this persistence demonstrates how mysteries maintain cultural significance long after they have ceased to be genuine scientific puzzles, becoming instead repositories for our fascination with the limits of knowledge itself. Consider the European eel, a creature that has confounded marine biologists for centuries with one of nature's most perplexing reproductive cycles. A journey so inexplicable that scientists still cannot fully explain how these fish navigate across thousands of miles of open ocean to reach a spawning ground they have never seen and to which they will never return. Baby eels, known as elvers, emerge from the depths of the Sargasso Sea somewhere in the middle of the Atlantic Ocean, drifting on ocean currents for up to 3 years, transforming gradually as they travel eastward toward the rivers and streams of Europe, Africa, and Asia, guided by mechanisms that remain fundamentally mysterious despite decades of intensive research. Once these juvenile eels reach freshwater environments, they spend anywhere from 5 to 20 years living in rivers and lakes, growing larger and developing the dark coloration of sexually mature adults, during which time they never once reproduce, never show any interest in breeding, and give absolutely no indication of their purpose in these inland waters. Then, as if responding to an invisible signal that scientists have failed to identify, these fully mature eels stop feeding entirely, their digestive systems begin to shut down, their eyes enlarge, and they inexplicably transform into what researchers call the silver eel stage, a metamorphosis triggered by some unknown environmental cue or internal biological clock that compels them to abandon their freshwater homes and swim back toward the Atlantic Ocean, retracing routes they have never traveled. What makes this phenomenon even more bizarre is that eels captured during this migration have been tracked attempting to cross land barriers, climb waterfalls, and traverse seemingly impossible terrain in their desperate drive to reach the sea. And yet upon reaching the ocean, these eels dive deeper and deeper, swimming into depths where the pressure would crush most fish, where darkness is absolute, and where the conditions seem entirely incompatible with reproduction. No scientist has ever observed eels actually spawning in the wild, no larval stage has been definitively traced back to adult eels, and the entire reproductive process remains cloaked in mystery, existing as one of biology's most profound unknowns, despite the fact that eels are found throughout the world and have been studied extensively for generations. The psychological mechanism behind our acceptance of this mystery lies in the way we have normalized the unknown, compartmentalizing eel reproduction as simply another strange fact of nature, rather than recognizing it as a fundamental gap in our understanding of biological systems. And we continue to accept that these creatures embark on journeys that kill them, that serve no observable purpose, and that operate according to rules we cannot decipher. All while maintaining complete confidence in our scientific knowledge. Consider for a moment the experience of a person who, when they hear the number 5, genuinely perceive the color blue, or when they taste the flavor of cinnamon, they simultaneously experience the texture of velvet against their skin, or when they read a particular word, they involuntarily sense a specific spatial location in the air before them. This is synesthesia, a neurological phenomenon in which stimulation of one sensory pathway automatically and involuntarily triggers experiences in another sensory pathway, creating a binding between senses that most of us would consider entirely separate and independent from one another. The person experiencing synesthesia is not confused or making a metaphorical association. They are genuinely perceiving what they describe, and these cross-sensory experiences occur instantly and consistently every single time they encounter the trigger stimulus. A synesthete might insist that the letter C is always and without exception a shade of orange, or that Tuesday mornings feel inherently purple, and they will describe these experiences with absolute certainty because to them, the sensation is as real and immediate as any conventional perception we might have. The brain in these individuals has formed unusual neural connections between regions that typically operate independently, perhaps between the visual cortex and the auditory cortex, or between areas responsible for processing taste and those responsible for spatial awareness. Most neuroscientists believe this occurs due to variations in how neural pathways develop during childhood, possibly involving a failure of the brain's typical process of neural pruning, where unnecessary connections are eliminated during development. Some researchers have suggested that everyone possesses these cross-sensory connections to some degree, but in most people, these connections remain subdued or are actively suppressed by inhibitory mechanisms in the brain, whereas in synesthetes, these connections are either more robust or the inhibition is weaker. What makes synesthesia genuinely bizarre from a scientific perspective is not simply that it occurs, but that it persists as a legitimate and measurable aspect of human neurology despite having no apparent evolutionary advantage, no clear survival mechanism, and no reason why natural selection would preserve it across human populations. The condition remains largely unchanged throughout a person's life, suggesting deeply ingrained neural architecture, yet it does not impair the individual's ability to function or perceive the world conventionally when they choose to focus on standard sensory processing. Imagine waking up one morning and feeling an itch on your left hand, so you instinctively reach over to scratch it, only to remember that your left hand was amputated 3 years ago. This is the lived reality for millions of people across the world who experience what neuroscientists call phantom limb sensations, a phenomenon so deeply strange and persistent that it challenges our fundamental understanding of how the body and brain communicate. The sensation is not imaginary or psychological in nature, though it exists entirely within the neural landscape of the patient's mind. People report experiencing vivid, intense physical sensations emanating from limbs that no longer exist, including itching, burning, tingling, pain that can range from mildly uncomfortable to absolutely excruciating, and even the sensation of movement in the absent limb. Some individuals describe feeling their phantom fingers clenched into a fist, or experiencing the phantom leg positioned in an awkward angle that would be impossible if it were still attached to their body. The sensations can persist for decades after amputation, and in some cases, they never fully disappear regardless of medical intervention or psychological processing. What makes this phenomenon so deeply puzzling is that the brain somehow maintains a neural map of body parts that no longer provide any sensory input whatsoever, continuing to generate signals and sensations as though the limb remains fully intact and functional. Neuroscientists theorize that the brain retains what is called a body schema, a comprehensive internal model of the body's physical structure that develops throughout childhood and becomes deeply embedded in the neural architecture over a lifetime of embodied experience. This neural representation exists independently of actual sensory input, meaning that even when the peripheral nerves can no longer send signals to the brain because the limb itself has been surgically removed, the brain's internal map persists, continuing to generate sensation and awareness as though the connection remains active. The phantom sensations may arise from the brain's attempts to interpret conflicting or ambiguous signals from the amputation site, or from the spontaneous firing of neurons in the sensory and motor cortex that previously received input from the missing limb. Some researchers suggest that the brain, suddenly deprived of the expected sensory feedback from a limb, may generate these phantom sensations as a form of neurological noise or confusion, a glitch in the system that demonstrates just how deeply the body's physical presence is wired into our neural structure. What is truly remarkable is how universally this phenomenon persists despite modern medicine's extensive knowledge of neurology, and despite the fact that phantom sensations have absolutely no adaptive function whatsoever. They serve no purpose, provide no useful information, and yet the brain cannot seem to stop generating them. In the 1970s, humanity launched two spacecraft named Pioneer 10 and Pioneer 11 into the vast expanse of the solar system, and these missions represented some of our greatest achievements in space exploration, carrying golden records and messages from Earth far beyond the reaches of our home planet. As these vehicles traveled deeper into space at tremendous velocities, scientists on Earth tracked them meticulously using radio signals, measuring their positions and trajectories with extraordinary precision. And for decades, the data seemed to align perfectly with the laws of physics and our understanding of gravitational forces. However, beginning in the 1980s and becoming increasingly undeniable through the 1990s, researchers discovered something profoundly unsettling. Both Pioneer spacecraft were gradually slowing down more than they should have been, experiencing an unexplained deceleration of approximately 1/10 billionth of Earth's gravity, a minuscule force that nonetheless defied explanation and seemed to pull at the very foundations of our physical understanding. The anomaly was so subtle that it took years of precise measurements to confirm it was real and not merely instrumental error or miscalculation. Yet once confirmed, it sparked enormous scientific curiosity and considerable concern among the physics community. Scientists proposed numerous theories to explain this mysterious deceleration, suggesting everything from undetected solar wind particles pushing against the spacecraft to thermal radiation being emitted unevenly from the probes themselves, creating tiny jets of heat that could act like miniature rocket thrusts in unexpected directions. They examined the possibility of unknown massive objects lurking in the outer solar system, considered whether the fabric of spacetime itself behaved differently at such vast distances, and even entertained more speculative ideas about modifications to Einstein's theory of gravity or new physics operating at cosmic scales. Yet despite these investigations and hypotheses, the Pioneer anomaly persisted as a genuine mystery, a small yet unmistakable discrepancy between prediction and observation that seemed to mock our confident assertions about understanding the universe. The psychological impact of this anomaly lay in how it revealed the limitations of human knowledge despite our technological sophistication, demonstrating that even our most careful measurements and our most elegant theories could encounter phenomena that defied easy explanation. What made this phenomenon particularly compelling was its quiet persistence, the way it continued to exist in the data year after year, a small voice suggesting that something fundamental about our understanding might be incomplete. Deep within the ocean waters, there exists a creature that appears to have found a way to circumvent the most fundamental rule of existence, the inevitability of aging and death, and this organism is the immortal jellyfish, scientifically known as Turritopsis doanea, a small translucent creature roughly the size of a human fingernail that possesses what might be described as biological time travel, or perhaps more accurately, a form of cellular regeneration that allows it to revert from its mature adult form back into its juvenile polyp stage whenever it faces stress, injury, or the approach of death. When a typical jellyfish reaches the end of its lifespan or encounters conditions it cannot survive, it simply dies and decomposes into the ocean floor. But the immortal jellyfish, in what seems like an act of defiance against mortality itself, undergoes a process called transdifferentiation, where its cells essentially rewrite their own identity, transforming from the specialized cells of an adult jellyfish back into the unspecialized cells of a juvenile form, allowing the organism to essentially restart its entire life cycle from the beginning, an almost miraculous reversal that means theoretically, a single immortal jellyfish could live forever, reproducing and resetting itself endlessly across millions of years. The mechanism behind this phenomenon appears to involve the jellyfish's remarkable ability to reprogram its cellular machinery, essentially turning back its biological clock through processes that scientists are still working to fully understand, though research suggests that the organism can manipulate genes associated with development and growth, essentially telling its own cells to forget what they have learned and to become young again. A process that defies our conventional understanding of how aging works in most living creatures. What makes this biological reality even more perplexing is that this ability seems to persist despite having no apparent logical evolutionary advantage beyond mere survival, and yet the immortal jellyfish continues to thrive in the oceans, occasionally being transported around the world in the ballast water of cargo ships, spreading its population across new ecosystems where it sometimes becomes an invasive species. A creature that cannot die spreading into environments where it was never meant to exist, challenging our assumptions about what life should be and how it should end. Yet despite this apparent invulnerability, the immortal jellyfish remains vulnerable to predation, disease, and environmental toxins, reminding us that even biological immortality cannot guarantee eternal existence in a world fraught with countless threats, and that the ability to reset one's cells is ultimately just another strategy for survival, no more guaranteed to succeed than any other creature's desperate struggle against the indifferent forces of nature. Deep beneath the ocean's surface, in the crushing darkness where sunlight cannot penetrate, exists a creature whose cognitive abilities challenge everything we understand about how intelligence should develop and manifest in the natural world. The octopus, an invertebrate mollusk with no centralized brain structure comparable to vertebrates, possesses problem-solving capabilities, tool use, and behavioral flexibility that rival or exceed those of many creatures we consider far more intelligent. Yet the mechanism by which this intelligence emerges remains profoundly mysterious to marine biologists and neuroscientists alike. An octopus can open child-proof containers, navigate mazes with remarkable efficiency, recognize individual humans, solve puzzles that require multiple steps of reasoning, and even demonstrate what appears to be play behavior, all while possessing a distributed nervous system where approximately 2/3 of its neurons reside not in its brain but throughout its 8 arms, functioning with a degree of autonomy that suggests something fundamentally different from centralized consciousness as we understand it. This distributed neural architecture means that each arm can essentially think and act somewhat independently, processing sensory information and executing complex motor tasks without requiring constant input from the central brain, yet somehow this fragmented system produces coordinated, intelligent behavior that suggests either a form of consciousness we have yet to properly conceptualize or a mechanism of biological organization that transcends our current models of intelligence entirely. The psychological framework through which we typically understand intelligence depends heavily on centralization, on the idea that a unified command center processes information and makes decisions. Yet the octopus violates this assumption fundamentally while still demonstrating learning, memory formation, behavioral adaptation, and problem-solving that by all practical measures constitutes genuine intelligence. Scientists have documented octopuses using coconut shells as portable shelters, carrying them across the seafloor and assembling them into protective structures, behavior that requires not only tool recognition, but planning, foresight, and the understanding of cause and effect. And yet we still cannot fully explain how an animal with such an alien neurological organization develops and executes such behaviors. Deep within the cosmos, galaxies across an entire region of space are moving in a direction that defies our current understanding of the universe's structure, all being pulled toward an invisible point in space that scientists have named the Great Attractor, a gravitational anomaly so vast and so mysterious that it challenges our fundamental comprehension of how gravity works on the largest scales imaginable. This phenomenon was first discovered in the 1980s when astronomers noticed that our own Milky Way galaxy, along with tens of thousands of other galaxies in our local region, were all moving through space at velocities that couldn't be explained by the observable matter and gravitational sources we could see. As if something invisible and immensely powerful was drawing these vast structures toward a specific point, located approximately 250 million light-years away in the direction of the constellation Centaurus. The Great Attractor is not a black hole or a single massive object, but rather appears to be a concentration of dark matter and possibly missing mass that forms a region of space where gravity becomes so dominant that it bends the trajectories of entire galactic superclusters, pulling them inexorably toward this cosmic focal point in a way that seems to operate outside the normal rules we've established for gravitational interaction. What makes this phenomenon so deeply unsettling to scientists is that all of our calculations, all of our models, all of our sophisticated instruments and observations cannot fully account for the amount of gravitational force that would be necessary to produce such a universal pulling effect, suggesting that the majority of matter causing this attraction remains completely invisible to us. Hidden within the structure of dark matter itself, or perhaps representing something we haven't even theorized yet. The persistence of this mystery, despite decades of intensive study, reveals a humbling truth about modern astronomy and physics. We can measure the motion of the galaxies, we can chart their movement through space with extraordinary precision, we can calculate their velocities and trajectories with remarkable accuracy, and yet we cannot explain what is causing them to move, which means we are left observing the effects of forces we do not understand, tracking the influence of matter we cannot detect, and acknowledging that something fundamental about the nature of gravity and the distribution of mass in the universe remains completely beyond our current grasp, a gap in knowledge that persists not because scientists lack the will to understand it, but because the universe has hidden something so vast and so elemental that even our most advanced instruments and theories cannot yet penetrate its secrets. Imagine, if you will, that somewhere in the vast darkness of space, powerful bursts of radio energy are exploding across the cosmos with such intensity that they release as much energy in a single millisecond as our sun produces in an entire day, and yet we have almost no idea where they come from or what creates them. These phenomena are known as fast radio bursts, or FRBs, and they represent one of the most perplexing mysteries that contemporary astronomy has encountered in recent decades. These bursts appear suddenly in the radio spectrum, lasting only milliseconds before vanishing entirely, leaving astronomers scrambling to point their instruments in the right direction before the signal disappears forever. The first fast radio burst was discovered in 2007 when researchers were combing through archival data collected by a radio telescope, and since that initial discovery, hundreds more have been detected, each one appearing to originate from different parts of the observable universe. The signals are so brief and so unpredictable that capturing detailed information about them feels almost like trying to photograph lightning with a camera that doesn't have autofocus. What makes these bursts particularly fascinating from a psychological standpoint is that their very existence challenges our fundamental assumptions about how the universe operates and what physical processes should be occurring at cosmic scales. We have developed elegant theories to explain nearly every other phenomenon we observe in space, from the birth of stars to the collision of galaxies, and yet fast radio bursts somehow evade all conventional explanation. Some researchers have proposed that they might originate from magnetars, which are neutron stars with extraordinarily powerful magnetic fields, while others have suggested they could be the result of colliding neutron stars, or perhaps even the signatures of exotic physics that our current models simply do not account for. The scientific community has normalized this uncertainty by treating it as a fundamental research frontier, an area where new discoveries are not just possible but actively expected. We have accepted that we live in a universe that occasionally produces signals we cannot immediately decode, and rather than viewing this as a failure of our understanding, we have reframed it as an invitation to develop better instruments and more sophisticated detection methods. The Breakthrough Listen project, the most comprehensive search for extraterrestrial intelligence ever conducted, has begun examining fast radio bursts as potential technological signatures. Though most astronomers remain confident that natural astrophysical processes, however exotic and poorly understood, offer the most plausible explanation for what we are detecting. Deep beneath the arid plains of East Africa, in the sprawling underground tunnel networks of Kenya, Ethiopia, and Somalia, there exists a creature so peculiar in its biological construction that it seems almost engineered by some force outside the normal rules of mammalian evolution. And this creature is the naked mole rat, a small, wrinkled, nearly hairless rodent that possesses an immune system so extraordinarily specialized and resilient that it defies many of the conventional understanding that scientists have developed about how vertebrate defenses should function. The naked mole rat lives in colonies that can number up to 300 individuals, existing in hot, oxygen-poor underground chambers where they work together in a eusocial structure much like bees or ants. And yet, despite living in densely packed underground conditions where disease and infection should theoretically run rampant through the population, these creatures almost never develop infections, rarely develop cancers, and exhibit virtually no signs of sepsis, even when exposed to bacteria that would prove rapidly fatal to any other mammal of comparable size. What makes this phenomenon even more bewildering is that the immune system of the naked mole rat operates through mechanisms that seem almost deliberately counterintuitive, employing specialized immune cells and chemical compounds that work in ways entirely foreign to the immune responses we observe in mice, rats, humans, and most other well-studied mammals, suggesting that somewhere along the evolutionary timeline, these creatures took a completely different immunological path. Scientists have discovered that naked mole rats produce exceptional quantities of a substance called high molecular weight hyaluronic acid, a compound that coats their cells and seems to provide a protective barrier that prevents infection and inhibits the growth of malignant tumors. And they also possess altered versions of genes related to pain and inflammation, meaning that their bodies do not respond to injury the way ours do. And this, combined with their apparently infinite capacity to generate effective immune responses, has made them nearly invulnerable to the diseases that decimate other rodent populations. Yet, despite decades of intensive research, despite the fact that understanding the naked mole rat's immune system could revolutionize human medicine and potentially unlock cures for cancer and infectious disease, the fundamental mechanisms remain elusive and incompletely understood. And we continue to study these creatures in laboratories while still unable to fully explain or replicate the biological advantages that have allowed them to thrive in conditions where virtually every other mammal would perish within weeks. The promise of translating their immunological secrets into therapies that could extend human health span remains tantalizingly out of reach, a biological treasure map whose coordinates we have yet to fully decipher. In 1984, scientists monitoring cosmic ray detectors in Utah made an observation so extraordinary that it defied nearly every prediction made by modern physics about the limits of natural phenomena in our universe. They detected a single subatomic particle, a cosmic ray of unimaginable energy striking Earth's atmosphere with such tremendous force that researchers famously named it the "Oh my God" particle simply because no other expression seemed adequate to capture their astonishment. This particle arrived carrying approximately 50 million times more energy than any cosmic ray that scientists had previously observed in their most sophisticated experiments, and it remains to this day one of the most powerful naturally occurring particles ever recorded by human instrumentation. The energy content was so remarkably high that it should have been physically impossible according to the Greisensatzepin-Kuzmin limit, a theoretical constraint suggesting that cosmic rays traveling vast distances through space should lose energy through interactions with the cosmic microwave background radiation, yet somehow this particle had arrived essentially undiminished. Scientists have spent decades attempting to understand where such a particle could have originated, what cosmic cataclysm could have accelerated it to such impossible velocities, and why the established laws governing particle physics seemed inadequate to explain its existence. The source of this particle remains genuinely unknown, though various theories propose supermassive black holes, neutron stars, or exotic astronomical phenomena beyond our current understanding as potential candidates. Despite decades of intensive study and the construction of increasingly sensitive detection equipment worldwide, astronomers have never identified a clear source region in the sky or definitively explained the mechanism that could have imparted such staggering energy to a single particle. The puzzle persists because our theoretical models seem incomplete, suggesting that either unknown astrophysical accelerators exist in the cosmos or our fundamental understanding of physics itself requires revision. What makes this particle particularly tantalizing is that its discovery represents a humbling reminder that the universe retains secrets we have yet to comprehend, and that nature continues to produce phenomena that challenge even our most carefully constructed scientific frameworks, inviting future generations of physicists to expand the boundaries of what we thought possible. The detection of the oh my god particle exemplifies science's greatest strength, the ability to encounter genuine mystery and respond with curiosity rather than complacency, ensuring that as long as instruments grow more sensitive and minds remain open to surprise, the cosmos will continue to reveal wonders that transform our comprehension of reality itself. Life on Earth operates on a profound asymmetry that remains one of the deepest mysteries in biochemistry and origin of life research, a phenomenon known as homochirality, where virtually all amino acids in living organisms exist in a single left-handed or right-handed configuration, specifically the left-handed form, while the right-handed mirror image versions are almost entirely absent from biological systems. When you examine the molecules that comprise every protein in your body, every enzyme that catalyzes your metabolism, and every structural element that gives your cells their form, you discover that they all twist in the same direction, a uniformity so complete and universal that it seems impossible this could have arisen by chance. Yet the chemical laws of nature provide no inherent reason why one-handedness should dominate over the other. In a prebiotic environment, before life emerged, chemical synthesis would have produced equal quantities of both left and right-handed amino acids in what chemists call a racemic mixture, a 50-50 distribution that reflects the perfect symmetry of physical chemistry, where neither form possesses any advantage over the other in terms of stability or reactivity under normal circumstances. Yet somehow, life selected one chiral form exclusively and rejected the other, and this selection occurred at the very moment life was emerging from non-living chemistry, establishing a constraint that persists to this day with remarkable consistency across all known biological systems. The mechanism that could have driven this preference remains unclear despite decades of investigation, with scientists proposing theories involving asymmetric environments, such as circularly polarized ultraviolet light from space, mineral surface catalysis with inherent chirality, or the amplification of tiny statistical advantages through self-replication feedback loops. Yet none of these explanations fully accounts for the completeness and universality of the pattern. We have largely normalized this profound asymmetry by accepting it as simply how life is, treating homochirality as a solved problem once we acknowledge that the first living systems locked into one configuration and then inherited this constraint through all subsequent evolution. But this normalization obscures the genuine mystery of how and why that initial lock-in occurred, leaving us with a universe that obeys perfectly symmetrical physical laws, yet somehow gave rise to organisms built exclusively from molecules of one-handedness. Every single day, without fail, you experience a phenomenon so common that you rarely stop to think about it, yet so deeply embedded in human behavior that it has persisted across every culture, every civilization, and every era of recorded history. You yawn. It happens when you wake up in the morning, when you sit through a boring meeting, when you see someone else yawn, when you're tired, when you're anxious, and sometimes for reasons that seem to have no connection to anything happening around you at all. The mechanics of a yawn are straightforward enough to observe. Your mouth opens wide, your jaw stretches, air rushes in through your mouth and out through your nose, your facial muscles contract, and then it passes, leaving you feeling slightly more alert or relaxed depending on the circumstance. But the question that science has struggled with for centuries is not what happens during a yawn, but rather why it happens at all and what biological purpose it actually serves. The traditional explanation, the one taught in schools and repeated in medical textbooks, is that yawning increases oxygen intake to your blood and brain, that it helps you stay awake when you are becoming drowsy, that it is simply your body's way of getting the oxygen it desperately needs. Yet research has consistently shown this explanation to be incomplete or perhaps even entirely incorrect. Studies measuring oxygen levels before and after yawning have found no significant increase in blood oxygen saturation, which would suggest that if yawning were truly about oxygen intake, it should be remarkably inefficient at its supposed job. Interestingly, yawning occurs most frequently when we are not tired, but rather when we are transitioning between states of consciousness, between focus and boredom, between rest and alertness, which suggests something far more complex is occurring beneath the surface of this simple reflex. Scientists have proposed alternative theories, that yawning helps regulate brain temperature by drawing cool air into the nasal passages and cooling the blood vessels surrounding the brain, that it stretches the muscles of the jaw and face to prevent stiffness, that it serves some kind of social signaling function that helped our ancestors coordinate group behavior and attention, or that it plays a role in mental state transitions by increasing arousal and cognitive function during moments of shifting awareness. What makes yawning truly bizarre is that despite having no clear evolutionary advantage, despite serving no obvious survival function, and despite being impossible to suppress even when you are fully aware that you are about to do it, it remains one of the most universal human behaviors. You cannot will yourself not to yawn when the urge strikes, yet you also cannot force a yawn simply by wanting one hard enough, which suggests some strange paradox in how your body prioritizes and executes this seemingly pointless action. Imagine sitting in a quiet room watching a video of someone speaking clearly and distinctly, their lips moving in perfect synchronization with the sounds you hear emerging from the speakers, and yet what your ears perceive is fundamentally different from what your eyes are witnessing. This is the McGurk effect, a peculiar phenomenon first documented in 1976 by psychologist Harry McGurk and his colleague John MacDonald, and it remains one of the most striking demonstrations of how profoundly our senses can deceive us through the most unexpected of collusions. When you watch a video of a person whose mouth is moving as though they are saying the syllable ba ba ba, while audio is playing the sound ga ga ga, something remarkable happens in your brain. You do not hear what your ears are actually receiving, nor do you see what your eyes are observing, but instead you perceive a completely different sound altogether, often something like da-da-da, a phantom phoneme that exists only in the intersection of sight and sound within your consciousness. The mechanism behind this extraordinary deception lies in the fundamental nature of how your brain processes sensory information, particularly in the way it integrates visual and auditory signals when they originate from the same source. Your brain is essentially a prediction machine, constantly trying to construct the most coherent and unified representation of reality by combining multiple streams of sensory data. And when your eyes see lip movements that correspond to one sound, while your ears hear something entirely different, your brain does not simply average these conflicting inputs or choose one over the other. Instead, it performs a kind of sophisticated negotiation, creating a third perception that somehow reconciles both visual and auditory information into a single experience that seems internally consistent. This integration happens so automatically and so seamlessly that most people are not even aware that what they are perceiving is a constructed illusion rather than a direct representation of external reality. The McGurk effect persists with striking robustness across different populations and languages, remaining powerful even after people are made explicitly aware of its mechanisms, and even after repeated exposure to the same stimulus, as though the lower levels of sensory processing in your brain continue to operate under their own rules regardless of what your conscious mind understands about the deception. What makes this phenomenon particularly fascinating is that it reveals a fundamental truth about human perception, that the boundary between seeing and hearing is far more fluid than we typically assume, and that our brains do not receive neat, separate streams of information from our different senses, but rather engage in continuous cross-modal communication where the signals from one sense routinely shape the interpretation of signals from another. In the depths of forest floors and the shadowed corners of decaying wood, there exists an organism so peculiar in its nature that it challenges our most fundamental understanding of what intelligence actually means. And this creature is the slime mold, a single-celled organism that possesses no brain, no neurons, no centralized processing system whatsoever, yet demonstrates problem-solving abilities and navigational behaviors so sophisticated that they rival the cognitive performances of animals with actual nervous systems. When researchers from various universities placed slime molds in maze-like laboratory configurations, they observed something that should not have been possible according to conventional biological understanding. The slime mold cells spread throughout the maze pathways, exploring every available route and dead end, and then, in a process still not fully understood by science, they somehow identified the shortest and most efficient path through the entire maze structure, withdrawing from dead-end corridors while reinforcing the optimal route with increased cellular mass and nutrients. The mechanism behind this apparent intelligence appears to involve chemical signaling and a form of computational processing that occurs at the cellular level itself, where the organism essentially uses its own distributed body as a biological computer, with each cell communicating with its neighbors through chemical gradients and molecular signals, creating a collective intelligence that emerges from the sum of countless microscopic interactions rather than from any single command center or brain. What makes this phenomenon so profoundly unsettling to our understanding of cognition is that we have traditionally defined intelligence as something that requires centralization, something that requires a brain or at least a nervous system to coordinate thoughts and decisions. Yet here exists an organism that operates with distributed processing, a system where no single part knows what the whole organism knows, where information spreads through chemical diffusion rather than electrical impulses. And yet it still somehow manages to make decisions, solve problems, and navigate its environment with an efficiency that seems almost deliberately optimized. Scientists have attempted to explain this through various frameworks including emergent complexity and swarm intelligence principles. Yet the slime mold persists in demonstrating capabilities that exceed what these models would predict, and we continue to normalize this impossibility by simply categorizing it as a curiosity of nature rather than reconsidering what intelligence fundamentally is. Treating the slime mold as an exception rather than recognizing that perhaps our definitions have been wrong all along. In the moments before or during significant seismic events, witnesses across cultures and centuries have reported seeing luminous phenomena stretching across the night sky, brilliant flashes of light that dance between clouds, or strange glowing orbs that hover above the ground in eerie silence, and these observations, known as earthquake lights or seismic luminescence, represent one of the most persistently documented yet scientifically perplexing aspects of earthquake activity that continues to challenge our understanding of geological processes. The phenomenon has been recorded with remarkable consistency across vastly different regions and time periods, from ancient Chinese writings describing unusual sky illuminations preceding tremors, to modern eyewitness accounts from the 1995 Kobe earthquake, where thousands of people simultaneously observed strange blue and white flashes lighting up the night sky, to the 2011 Christchurch earthquake in New Zealand, where residents reported seeing brilliant auroras despite being nowhere near polar regions where such displays naturally occur. Scientists have proposed numerous explanations for these events, ranging from the piezoelectric effect, which suggests that stress on crystalline rocks in the Earth's crust generates electrical charges when compressed, to atmospheric ionization caused by radon gas released from fracturing rock, to electromagnetic pulses generated by the movement of massive geological structures. And yet, despite decades of investigation and the development of increasingly sophisticated monitoring equipment, no single explanation has gained universal acceptance or been definitively proven through controlled observation. The fundamental challenge lies in the spontaneous and unpredictable nature of earthquakes themselves, making it nearly impossible to position instruments precisely where and when these lights will appear, and the brief duration of the phenomena, often lasting only seconds, means that most observations come from eyewitness accounts rather than instrumental data, which introduces the complication of subjective interpretation and the human tendency to perceive patterns and assign meaning to unusual events. What remains particularly striking about earthquake lights is how they persist in our collective consciousness and scientific literature despite the absence of a unified theoretical framework, almost as though we have accepted that certain natural phenomena may operate according to rules we have not yet fully grasped. And this acceptance reflects a curious aspect of modern science, where phenomena too rare and unpredictable to study rigorously still command serious attention precisely, because the eyewitness evidence is so widespread and consistent that dismissing it entirely seems equally problematic as claiming complete understanding. Deep within the geological record of Earth's ancient past, scientists have discovered a profound paradox that challenges our understanding of planetary habitability and the nature of stellar evolution itself. Approximately 4.5 billion years ago, when our solar system was still in its infancy, the sun was significantly dimmer than it is today, radiating perhaps 30% less energy across the vast emptiness of space. Yet despite this dramatically reduced stellar output, geological and biological evidence suggests that liquid water flowed across Earth's surface, that life emerged from primordial oceans, and that the conditions necessary for the development of complex chemistry existed during this period of cosmic twilight. This contradiction, known as the faint young sun paradox, represents one of the most perplexing puzzles in planetary science. For the mathematics of stellar physics tells us that such a dim star should have left Earth frozen solid, locked beneath kilometers of ice and snow, with no possibility of the liquid water that we consider essential to all known life. The mechanism behind this persistent mystery involves a delicate interplay of atmospheric chemistry, greenhouse gas concentrations, and the early Earth's internal dynamics that we are only beginning to comprehend. During the Hadean and Archean eons, Earth's atmosphere contained vastly different proportions of gases compared to today, likely featuring higher concentrations of methane and carbon dioxide that would have created a potent greenhouse effect, trapping enough of the sun's faint radiation to maintain temperatures suitable for liquid water. Additionally, the young Earth possessed significantly greater internal heat from radioactive decay and the ongoing process of planetary differentiation, which may have contributed to surface warmth through volcanic activity and hydrothermal systems. Yet despite the logical frameworks we have constructed to explain this phenomenon, the faint young sun paradox continues to haunt planetary science, because we cannot fully account for how the atmospheric conditions and concentrations remained precisely calibrated across hundreds of millions of years to sustain habitability as the sun gradually brightened. We have normalized this mystery by accepting it as a problem to be solved through future research, a temporary gap in our knowledge rather than a fundamental challenge to our understanding of planetary habitability itself. Yet some researchers now propose that this very uncertainty may reveal something profound about life's resilience, that habitability itself is not a fixed target requiring precise calibration, but rather an emergent property capable of self-organization through the coupled evolution of atmosphere, geology, and biology, a system that actively maintains the conditions necessary for its own continuation. Deep within the realm of particle physics exists a peculiar measurement that has confounded scientists for decades, a tiny discrepancy that shouldn't matter but does, a ghostly whisper in the fundamental nature of reality that refuses to be explained by our most sophisticated theories. The muon, a particle roughly 200 times heavier than an electron, possesses a property called the magnetic moment, which describes how strongly it interacts with magnetic fields. And when physicists measure this property with extraordinary precision using sophisticated laboratory instruments, they consistently find that the actual value differs ever so slightly from what the standard model of particle physics predicts it should be. This difference is minuscule in everyday terms, yet it is significant enough that physicists cannot dismiss it as mere measurement error or instrumental limitation, because the precision of these experiments has reached such extraordinary levels that the equipment itself can measure effects of such minute proportions that we struggle to comprehend the scale. The muon anomaly persists as one of the most tantalizing hints that something exists beyond our current theoretical framework, some unknown particle or force interacting subtly with the muon and causing its magnetic moment to deviate from expectation. And for years, physicists have attributed this discrepancy to virtual particles that briefly flicker in and out of existence according to quantum mechanical principles, yet even accounting for these ethereal interactions. A gap remains. What makes this phenomenon particularly striking is that it occupies a strange middle ground in the landscape of experimental physics, too small to be definitively proven beyond the shadow of doubt, yet too persistent and reproducible to be easily ignored or forgotten, existing in that uncomfortable space where current theory cannot fully explain observations, but where the evidence itself remains tantalizingly incomplete. Scientists continue to refine their measurements with each passing year, hoping that eventually either experimental precision will reveal the discrepancy to be illusory, or that some new physics hiding in the equations will finally emerge to resolve this stubborn puzzle that has haunted particle physics since its discovery. Recent experiments at Fermilab have only intensified the mystery, confirming the anomaly with unprecedented precision and narrowing the possibilities for what might lie hidden beyond the standard model, whether exotic particles, extra dimensions, or forces yet to be discovered. In this way, the muon's subtle rebellion against theoretical prediction has become a beacon, drawing physicists toward deeper truths about the universe's fundamental architecture. The story of human blood types is one of science's most peculiar mysteries, sitting at the intersection of genetics, evolution, and questions we still cannot fully answer. When we examine the origins of the Abo blood group system that divides humanity into four primary categories, we find ourselves confronting a biological phenomenon that appears remarkably sophisticated, yet lacks a comprehensive evolutionary explanation. The Abo blood types are determined by antigens on the surface of red blood cells, controlled by a single gene with three possible variants, yet scientists cannot definitively explain why this system exists or what advantage it originally provided to our ancestors. What makes this particularly strange is that these blood types seem to have emerged relatively recently in evolutionary terms, yet they are distributed unevenly across different populations in patterns that suggest either random genetic drift or environmental pressures we have not yet identified. The O blood type, which lacks both A and B antigens, is the most common worldwide, yet it appears to be the most ancient, while the A and B types seem to have developed later through genetic mutations, possibly within the last 10,000 years or even more recently. This timeline troubles evolutionary biologists because the system is far too organized and widespread to be explained by simple chance. Yet no clear survival advantage has ever been demonstrated, making it impossible to apply the standard framework of natural selection to its emergence. When we consider the psychological and conceptual mechanisms that have perpetuated this mystery, we find that the blood type system has become so normalized in human culture that we rarely question its fundamental origins. People readily accept their blood types as fixed biological facts, understanding them through the practical lens of blood transfusions and medical necessity, but few contemplate the deeper question of why this system exists at all. The medical community long ago stopped asking this question, instead focusing on the practical applications of blood typing, which in turn reinforced the idea that understanding the origin was less important than understanding the function. This normalization has created a curious situation where something fundamentally unexplained has become universally accepted as understood, a phenomenon that persists despite the absence of any logical reason for it, revealing how easily human knowledge can become compartmentalized in ways that prevent us from acknowledging the boundaries of our understanding. The irony deepens when we realize that blood type distributions across populations might hold crucial clues to human migration patterns and environmental adaptation. Yet these patterns remain largely unexplored because the question itself has fallen out of favor within the scientific establishment. Imagine waking in the middle of the night to a sound so violent, so catastrophic, that your immediate instinct is to believe something has physically detonated inside your skull. Yet when you open your eyes and assess your surroundings with trembling hands, you find yourself completely intact, your room undisturbed, and no external source of the tremendous noise anywhere to be found. This is the lived experience of those who suffer from exploding head syndrome, a neurological phenomenon that has puzzled both patients and medical professionals for well over a century, characterized by the sudden perception of extraordinarily loud and disturbing noises that occur without any actual external sound being present. Often accompanied by bright flashes of light in the visual field and an overwhelming sense of panic that can take many minutes to subside even after the person has fully awakened. The sounds reported by sufferers are remarkably consistent despite the syndrome's rarity, typically described as explosions, gunshots, cymbals crashing with tremendous force, or the violent slamming of doors, and they occur most frequently during the transition between wakefulness and sleep, particularly in the hypnagogic state when the brain is beginning to shut down its sensory processing systems but has not yet fully disconnected from conscious awareness. The mechanism behind this strange affliction appears to involve a desynchronization between different regions of the brain during sleep onset, where the auditory cortex, which normally receives and interprets sound signals from the ears, somehow becomes activated and generates its own false sensory perception without any actual acoustic stimulus to justify it, and when combined with the temporary muscle atonia that accompanies REM sleep. The brain's inability to move the body can amplify the sense of danger and vulnerability that accompanies these auditory hallucinations. What makes exploding head syndrome particularly fascinating from a scientific perspective is that despite decades of neurological research, we still cannot definitively explain why some individuals experience this phenomenon while the vast majority never do. And we have no reliable treatment beyond reassurance and understanding that the condition, while terrifying, causes no actual physical harm and typically resolves on its own as the sufferer's sleep-wake cycle normalizes. Yet countless people continue to experience these episodes in isolation and fear, often believing they are experiencing something uniquely catastrophic and unknown, never realizing that there exists a medical category for their experience, illustrating how even in our modern age of advanced neuroscience and widespread medical information, the most bizarre functions of our sleeping minds remain inadequately understood and discussed in mainstream consciousness. High above the Earth, in the mesosphere where the atmosphere grows thin and the boundary between our world and space becomes increasingly blurred, there exists a phenomenon that defies easy explanation and challenges our fundamental understanding of atmospheric electricity. Red sprites are massive, luminous bursts of light that explode upward from the tops of thunderstorms, reaching altitudes of 50 to 90 kilometers into the sky, illuminating the darkness with ethereal red and blue glows that seem almost impossible given the conditions under which they occur. These optical events were first documented in 1989, yet they remained largely unnoticed by science for decades despite occurring regularly across the planet, primarily visible from high-altitude aircraft, satellites, and observers positioned at great distances from active storm systems. The sprites themselves are enormous, often spanning areas more than 50 kilometers wide, yet they flash into existence and vanish in mere milliseconds, making them extraordinarily difficult to observe and study with conventional instruments. They appear as jellyfish-like structures with luminous tentacles streaming downward, or sometimes as expanding rings of red light, accompanied by blue jets that shoot upward simultaneously, creating a visual display of such otherworldly beauty that early observers questioned whether their instruments were actually detecting real phenomena or merely recording instrumental artifacts and electromagnetic noise. The mechanism that produces these sprites involves an enormous electrical discharge occurring between a thunderstorm and the ionosphere itself, where the potential difference becomes so extreme that it ionizes the thin upper atmosphere, causing the nitrogen and oxygen molecules to glow with that distinctive red coloration. What makes this phenomenon particularly bizarre is that sprites should not exist according to classical models of atmospheric electricity, as the resistance of the thin upper atmosphere should prevent such powerful discharges from occurring, yet they appear to happen regularly, suggesting that our understanding of how electricity behaves in these extreme conditions remains fundamentally incomplete. Scientists have proposed various mechanisms involving stepped leaders, positive lightning, and electromagnetic interactions, yet significant uncertainties persist about the precise sequence of events that allows these massive charges to propagate upward from the storm to the ionosphere. Imagine standing in complete darkness, observing the universe around you, and trying to understand how it all moves together as one coherent system. For nearly a century, physicists have grappled with a mysterious force that seems to permeate all of space itself, a force so fundamental and so poorly understood that Einstein himself called it his greatest blunder, yet modern observations suggest it may be the most important ingredient in the cosmos. This is the cosmological constant, represented by the Greek letter lambda, and it remains one of science's most persistent and troubling enigmas. When Einstein first developed his general theory of relativity in 1916, he created a mathematical framework that described gravity not as a force pulling objects together, but as the curvature of spacetime itself caused by mass and energy. However, his equations suggested that a universe filled with matter should inevitably collapse under its own gravitational weight, contracting inward until everything converges into a single point. To prevent this catastrophic collapse and maintain a static, unchanging universe as he believed existed, Einstein introduced the cosmological constant into his equations, a term representing a uniform energy density spread throughout all of space that would counteract gravity's attractive pull. For decades, this remained a mathematical curiosity, an artificial fix to make the equations work as desired. Then in 1929, astronomer Edwin Hubble made observations that revolutionized our understanding when he discovered that distant galaxies were actually moving away from us, revealing that the universe was not static but expanding. Einstein immediately abandoned the cosmological constant, considering it unnecessary and calling its introduction the greatest mistake of his life. Yet the universe had the final word. In 1998, two teams of astronomers studying distant supernovae made an astonishing discovery. Not only is the universe still expanding, but this expansion is accelerating, speeding up over time rather than slowing down as gravity should cause. This acceleration has no explanation within our current understanding of physics, except for the resurrection of Einstein's cosmological constant, now interpreted as dark energy, an invisible component comprising roughly 70% of all mass and energy in the universe. We cannot see it, touch it, measure it directly, or explain what it fundamentally is, yet its gravitational repulsion appears to be the dominant force shaping the universe's evolution and ultimate fate. The persistence of this mystery, despite generations of investigation, reveals how little we truly comprehend about existence itself. Deep within the Maracaibo Basin of Venezuela, where the Catatumbo River flows into Lake Maracaibo, there exists one of the most remarkable and perplexing atmospheric phenomena known to science. A place where the sky seems to perpetually fracture with electrical discharge in patterns that defy conventional meteorological explanation. The Catatumbo lightning, as it has come to be known, occurs with such extraordinary frequency and intensity that locals have named it the Beacon of Maracaibo, a natural lighthouse that has guided sailors and fishermen for centuries with its relentless illumination. What makes this phenomenon so deeply unsettling to scientists and observers alike is that the lightning strikes occur almost continuously during certain seasons, with some accounts describing up to 280 lightning bolts per hour lighting up the night sky, creating an almost apocalyptic display of raw electrical power that seems to operate according to rules we do not fully understand. The region experiences this phenomenon primarily during the rainy season, typically from May through November, during which the sky above the river delta becomes a canvas of nearly constant electrical activity, transforming darkness into a surreal twilight that persists throughout the night hours. The prevailing scientific explanation attributes the Catatumbo lightning to a convergence of atmospheric and geographical factors that create the perfect conditions for lightning formation, including warm, moist air rising from the lake, cooler air descending from the Andes Mountains, and the presence of methane and other hydrocarbons being released from organic matter in the wetlands below. Yet this explanation, while logically sound in its construction, fails to account for the sheer intensity and frequency of the phenomenon, for even when we understand the mechanics of how lightning forms, we struggle to comprehend why this particular location generates such an overwhelming concentration of electrical discharge. Scientists have observed that the lightning here behaves differently from typical lightning in other regions, with the strikes often occurring in clusters, in patterns, and with a persistence that suggests something more complex than simple atmospheric chemistry is at work. The phenomenon has been measured and studied extensively, yet each investigation seems to raise more questions than it answers, leaving researchers in the position of observers documenting something they can describe but cannot fully explain. What remains perhaps most intellectually troubling about Catatumbo lightning is how readily we have accepted it as merely an extreme example of a well-understood process, when in reality, the concentration and behavior of the lightning defies easy categorization within our current models of atmospheric electricity. As you lie in bed at night, suspended in that delicate threshold between wakefulness and sleep, your body suddenly convulses with an involuntary jerk so violent that it jolts you back to consciousness, leaving your heart racing and your mind momentarily confused about what just happened. This phenomenon, known as hypnic jerks or sleep starts, affects the vast majority of human beings at some point in their lives, yet remains one of the most mysterious and poorly understood reactions our bodies produce during the transition into sleep. The experience typically involves a sudden, involuntary muscle spasm that can affect your entire body or just a single limb, and it often arrives accompanied by a sensation of falling, a dream fragment of stumbling, or sometimes simply the raw physical shock of the movement itself. Some people experience these jerks only occasionally, perhaps once or twice a month, while others find themselves jolted awake multiple times each evening, night after night, creating a frustrating cycle of interrupted sleep and mounting exhaustion. The intensity varies wildly from person to person and even from night to night within the same individual, ranging from barely noticeable twitches to full-body convulsions that can actually cause you to fall out of bed or wake your sleeping partner with the violence of the movement. Scientists and sleep researchers have proposed numerous explanations for why hypnic jerks occur, including theories rooted in evolutionary biology suggesting that our ancient ancestors needed to prevent themselves from falling out of trees during sleep, requiring some kind of startle mechanism to jolt them awake if they began to slip. Other researchers point toward the complex neurochemistry of sleep onset, theorizing that hypnic jerks result from a mismatch between the different systems in your brain that govern muscle control and consciousness, creating a brief moment of chaos where your voluntary muscles receive conflicting signals. Some studies have suggested that stress, caffeine consumption, vigorous exercise close to bedtime, and sleep deprivation can all increase the frequency and intensity of these jerks. Yet countless people report experiencing them even when they follow perfect sleep hygiene and maintain completely relaxed, stress-free lifestyles. The peculiarity that science struggles to fully explain is not merely why hypnic jerks happen, but rather why they persist so universally across human populations despite having no apparent modern function, why they remain largely uncontrollable even when we know they are coming, and why our conscious minds seem unable to prevent our sleeping bodies from producing these jarring interruptions that serve no clear physiological purpose in our contemporary existence. Deep within the churning chaos of an active volcanic eruption, where molten rock explodes skyward and ash clouds rise kilometers into the atmosphere, there exists a phenomenon so visually striking and scientifically perplexing that it challenges our fundamental understanding of how electrical discharge forms in Earth's atmosphere. Volcanic lightning, the brilliant and violent flashes of electricity that arc through the dense ash columns during eruptions, represents one of nature's most bewildering contradictions, occurring in an environment that should theoretically prevent lightning from forming at all. When a volcano erupts with particular intensity, the eruption column rises with tremendous speed, carrying vast quantities of fragmented rock, ash particles, and superheated gases upward into the lower atmosphere, creating a towering column of material that can reach heights of 20, 30, or even 40 kilometers above the volcanic vent. Within this swirling maelstrom of particles and energy, electric charges begin to accumulate and separate, leading to the sudden and spectacular discharge of lightning that illuminates the ash cloud from within, creating a mesmerizing and terrifying display visible for hundreds of kilometers. The mechanism behind this phenomenon remains incompletely understood by volcanologists and atmospheric physicists, though current theories suggest that the collision of ash particles, the friction between rapidly moving air masses, and the interaction of charged ice crystals within the eruption column generate the electrical potential necessary for lightning formation. Unlike ordinary thunderstorms, where moisture in the atmosphere provides the primary mechanism for charge separation, volcanic lightning appears to develop through the mechanical interaction of solid particles and the extreme temperatures within the eruption column, creating an entirely different electrical environment. Yet despite decades of scientific study and numerous expeditions to observe volcanic lightning at active eruption sites around the world, many aspects of how and why this lightning forms remain shrouded in mystery and contradiction. We have documented volcanic lightning at eruptions from Iceland to Indonesia, from Chile to the Philippines, and in each instance, the lightning behaves according to patterns that defy simple explanation, sometimes occurring in eruption columns that conventional atmospheric models suggest should not produce electrical discharge at all. This phenomenon has been observed and recorded throughout human history, yet our modern understanding of it remains fragmented and incomplete, suggesting that volcanic lightning operates according to principles we have not fully grasped, persisting in the margins of our scientific knowledge like a reminder that even in our age of advanced instrumentation and theoretical sophistication, the natural world continues to produce phenomena that elude our attempts at comprehensive explanation. Approximately 10% of the global human population identifies as left-handed, a neurological trait that has persisted throughout recorded history despite centuries of social pressure, institutional resistance, and what many would call systematic discrimination against those who naturally favor their non-dominant hand. When we observe left-handed individuals in their daily lives, we encounter a fundamental peculiarity of human neurology that science has struggled to fully comprehend. For the prevalence of left-handedness remains oddly consistent across cultures, time periods, and geographical regions, suggesting something deeply embedded in our biological architecture that actively resists elimination or correction. The mystery deepens when we consider that left-handedness appears to be heritable, yet it does not follow simple Mendelian patterns of inheritance, and approximately 70% of left-handed children are born to right-handed parents, a statistical anomaly that defies straightforward genetic explanation and hints at more complex neurological mechanisms at work during fetal development and early childhood brain formation. Scientists have proposed numerous theories to account for this phenomenon, ranging from differences in cerebral hemisphere dominance to variations in prenatal hormone exposure, particularly testosterone levels in the womb. Yet none of these explanations fully account for why left-handedness persists at such a consistent rate, or why it occasionally clusters within certain families while remaining absent in others despite identical genetic backgrounds. Throughout history, societies have attempted to eradicate left-handedness through forced correction in schools, religious institutions, and homes, yet the trait stubbornly resurfaces in each generation at remarkably similar percentages, as though some fundamental biological imperative maintains its presence in human populations regardless of external pressure to conform to right-handed norms. What makes this phenomenon particularly puzzling is that it offers no obvious evolutionary advantage, yet it has not been selected against despite its apparent inconvenience in a predominantly right-handed world, suggesting that either the disadvantage is minimal enough to be outweighed by other factors, or that left-handedness is somehow linked to other heritable traits that do confer selective benefits. The persistence of left-handedness, despite such consistent historical resistance to its expression, remains one of those quiet neurological mysteries that continue to elude definitive explanation, reminding us that the human brain contains mechanisms and predispositions that operate beyond our full understanding or control. Deep within the realm of particle physics, there exists a measurement that should be straightforward, almost elementary, yet it has become one of the most perplexing anomalies in modern science, a mystery that challenges our fundamental understanding of how matter behaves at its most basic level. The proton, that tiny positively charged particle nestled at the heart of every atom, possesses a radius, a physical dimension that scientists have been attempting to measure with increasing precision for decades. Yet every time they refine their techniques and conduct new experiments, they arrive at conflicting results that simply cannot be reconciled with established theory. For nearly a century, physicists believed they had a reasonable grasp of the proton's size, estimating its radius to be approximately 0.87 femtometers, a measurement derived from decades of scattering experiments where electrons collided with protons and their behavior revealed clues about the proton's structure and dimensions. However, when researchers began using muons, particles similar to electrons but significantly heavier, in the same experimental setup, measuring how these muons orbited around the proton in exotic atoms called muonic hydrogen, they discovered something profoundly troubling. The proton appeared to be about 4% smaller than previous measurements indicated, a discrepancy that might sound trivial until one considers that physics at this scale demands precision far beyond what such a difference represents. This contradiction between the electron-based measurements and the muon-based measurements created what scientists now call the proton radius puzzle, a genuine crisis in fundamental physics, because the standard model of particle physics offers no explanation for why these two independent measurement methods should yield different values when measuring the same physical property of the same particle. The psychological mechanism underlying this puzzle involves our deep reliance on consistency and our assumption that reality operates according to unified principles. When we measure something using two different approaches, we expect convergence upon the true value, not divergence, and the brain struggles to integrate this contradiction into its existing framework of how nature works. Scientists have proposed numerous explanations ranging from undiscovered particles that might affect muonic hydrogen in ways they do not affect normal hydrogen, to fundamental revisions of our understanding of quantum electrodynamics, to the possibility that muons and electrons somehow interact with protons in ways we have not yet comprehended. Yet none of these proposals has achieved consensus or definitively resolved the discrepancy. Consider the peculiar experience of having a song stuck in your head, repeating endlessly without your conscious invitation or control, a phenomenon that neuroscientists and psychologists have termed an earworm, and which most people have experienced at some point in their lives with startling regularity and persistence. You might hear a song on the radio during your morning commute, and suddenly, for hours or even days afterward, the same melody loops relentlessly through your mind, playing and replaying like a broken record that exists only within the architecture of your own consciousness, interrupting your thoughts during work, following you into conversations, and even intruding upon your attempts to fall asleep at night. The song typically plays in fragmented sections rather than complete versions, often just the chorus or a particularly catchy hook, repeating in a rhythmic pattern that seems designed specifically to burrow deeper into your awareness the more you try to suppress it. What makes earworms so bizarre is that they represent a form of involuntary musical memory that operates independently of your intentions, a mental process that science has only begun to understand in recent years through neuroimaging studies and behavioral research. The mechanism appears to involve the auditory cortex and the motor areas of the brain becoming activated in patterns that simulate actual music listening, as though your neural networks have essentially hijacked a portion of your cognitive resources to continue processing and replaying a musical sequence. Research suggests that earworms are more likely to occur with songs that have simple, repetitive melodies and lyrics, as these characteristics make the song easier for your brain to encode and reproduce in this involuntary manner. The phenomenon also seems to be triggered more frequently when you are tired, stressed, or engaged in mundane activities that do not require full cognitive attention, allowing your mind to wander into these musical loops almost by default. What remains genuinely puzzling is that despite our considerable understanding of how memory works and how the brain processes sensory information, we still have no reliable method to remove an earworm once it has taken hold, no technological solution or psychological technique that works universally across all individuals and all earworms. We have normalized this strange occurrence so completely that we rarely stop to consider how odd it truly is that our brains can spontaneously generate the experience of hearing music that is not actually present in our environment, a kind of auditory hallucination that society has deemed entirely harmless and even somewhat amusing, yet which represents a form of mental activity that continues to elude complete scientific explanation. Perhaps what makes earworms most intriguing is that they reveal the independent agency of our brains, demonstrating that consciousness itself is far more fragmented and autonomous than we typically assume. When spacecraft travel through our solar system, physicists have discovered something profoundly unsettling that defies conventional understanding of gravity and motion. As various probes and satellites make their closest approaches to Earth, performing what are called gravity assist maneuvers to gain speed and momentum for deeper space exploration, they occasionally experience unexpected changes in their velocities that cannot be accounted for by any known physics. The Galileo spacecraft, which flew by Earth in 1990 and again in 1992, exhibited small but measurable increases in speed that should not have occurred according to our most fundamental equations of celestial mechanics. Similarly, the NEAR spacecraft, the Cassini orbiter, and several other missions have all demonstrated these mysterious accelerations during their Earth flybys, each one slightly different in magnitude and character, yet each one fundamentally inexplicable within our current theoretical framework. These anomalies are typically quite small, measured in millimeters per second, yet they are consistently detected and verified by multiple independent measurements, making them impossible to dismiss as mere instrumental error or statistical noise. What makes this phenomenon particularly vexing for the scientific community is that the anomalies do not follow a predictable pattern that might suggest a simple missing force or misunderstood variable. The velocity changes seem to correlate mysteriously with the rotation of Earth itself, appearing larger when the spacecraft approaches from certain angles or at certain times, suggesting that something fundamental about our planet's rotation or mass distribution interacts with passing objects in ways that our gravitational models simply do not capture. Engineers and physicists have proposed numerous explanations, from errors in relativistic calculations to unaccounted atmospheric drag to hypothetical dark matter concentrations around Earth. Yet none of these theories have gained definitive support or successfully predicted all observed instances of the anomaly. The scientific community has largely maintained a posture of cautious skepticism toward the flyby anomaly, neither fully embracing it as evidence of new physics nor completely dismissing it, because to do either would require admitting either a fundamental gap in our understanding or that our instruments are systematically deceiving us in ways we do not yet understand. This liminal state of uncertainty persists year after year, decade after decade, as spacecraft continue their missions and continue to exhibit these small, reproducible, yet utterly mysterious deviations from predicted behavior, serving as a quiet reminder that even in our seemingly well-understood realm of classical mechanics and orbital dynamics, nature still harbors secrets that we have not yet learned to read. Lithium stands as one of the most peculiar paradoxes in modern medicine and neuroscience, a substance so chemically simple yet so profoundly enigmatic in its effects that scientists have studied it for over a century without arriving at a complete understanding of how it actually works. When lithium salts were first discovered to stabilize mood in patients with bipolar disorder during the 1949, it represented a genuine breakthrough in psychiatric treatment. And yet today, despite its widespread clinical use and proven efficacy in preventing manic episodes and reducing suicide risk, we still cannot explain with certainty the precise mechanism by which this element alters brain chemistry and behavior. Lithium is so small, so basic in its atomic structure, containing only 3 protons and neutrons in its nucleus, that it seems almost impossible that something so elementary could be so therapeutically powerful, yet the evidence remains undeniable that it works for many patients who take it. The problem deepens when we consider that lithium operates differently in different people, that some patients respond dramatically while others show no response whatsoever, and that the therapeutic window between an effective dose and a toxic dose is dangerously narrow, requiring constant blood monitoring to keep patients safe. Scientists have proposed numerous theories over the decades that lithium affects neurotransmitter systems like serotonin and norepinephrine, that it modulates protein kinase C signaling, that it increases brain-derived neurotrophic factor, that it affects gene expression patterns. Yet none of these theories fully explains the complete clinical picture we observe. The strange truth is that we have learned to accept this fundamental gap in our knowledge, to prescribe a medication whose benefits we can measure and whose dangers we can monitor, while remaining essentially ignorant about the basic question of why it works at all. This represents a kind of intellectual compromise that runs counter to our modern scientific expectation that medications should have well-understood mechanisms of action before widespread use. And yet the clinical reality proves so convincing that we have simply incorporated lithium into our therapeutic arsenal despite this missing piece of understanding. Perhaps this acceptance reveals something important about the limits of scientific knowledge itself, that empirical effectiveness sometimes must precede mechanistic understanding, and that our obligation to relieve human suffering can justify therapeutic use even when the underlying biology remains opaque, a humbling reminder that medicine is not always a deductive science flowing from first principles downward, but sometimes an inductive one built from clinical observation upward. Yet lithium also forces us to confront a deeper question, whether our drive to understand mechanism might sometimes obscure the more pragmatic wisdom of simply following what works, even in darkness. High above the Gulf of Carpentaria in northern Australia, observers have documented one of the most peculiar and visually arresting meteorological phenomena on Earth, a formation known as morning glory clouds, which appear as solitary, towering waves of cloud that stretch across hundreds of kilometers of sky during the early morning hours, often rolling across the landscape with such distinctive undulating patterns that they seem almost impossible. As though the atmosphere itself has taken on physical properties that should not exist according to our conventional understanding of cloud dynamics and atmospheric behavior. These remarkable formations typically manifest as single or multiple elongated tubes of cloud that can measure up to 1,000 kilometers in length while remaining only a few hundred meters tall, presenting themselves as enormous cylindrical structures suspended in the atmosphere with sharp, defined edges that create an almost sculptural appearance, and they move deliberately across the landscape like waves frozen in three-dimensional space. Rolling forward with a consistent velocity and maintaining their coherent structure despite the turbulent and chaotic nature of the atmosphere through which they travel. The mechanism behind these clouds involves complex interactions between weather systems, land and sea breeze boundaries, and gravity waves that propagate through atmospheric layers, where cooler air masses collide with warmer ones along convergent zones, triggering condensation that outlines these invisible waves of air movement. Yet the precise conditions required for their formation remain incompletely understood by meteorologists. With researchers continuing to investigate why these clouds manifest so reliably in specific geographic regions, while remaining absent from most other areas of the planet, despite similar meteorological conditions occurring elsewhere. What makes morning glory clouds particularly remarkable is not merely their stunning visual appearance or their enormous scale, but rather the fact that they persist as a documented phenomenon that challenges our fundamental understanding of atmospheric stability in cloud formation, representing a situation where something extraordinary has become so regularly observed that we have essentially normalized it. Accepting it as simply another aspect of how weather operates rather than recognizing it as a profound mystery that reveals the gaps in our atmospheric knowledge. And observers who witness these formations often report a profound sense of awe and disorientation, confronted with visual evidence that the sky operates according to principles far more complex and mysterious than our simplified models suggest. You are driving down a long, straight highway on a clear afternoon, and the miles stretch out before you in an endless ribbon of asphalt and white line markings that pulse rhythmically past your windshield like a hypnotic pulse. Your hands rest on the steering wheel, your eyes fixed on the road ahead, and somewhere between the first hour and the third hour of your journey, you realize that you cannot recall the last 30 minutes of driving with any clarity whatsoever. You have no memory of passing specific exits, no recollection of the towns you drove through, no awareness of how many miles have accumulated behind you, and yet here you are, still driving safely, still maintaining your lane, still responding to traffic signals and other vehicles as though some part of your consciousness remained engaged while your awareness drifted into an almost dreamlike state. This phenomenon is called highway hypnosis, and it represents one of the most peculiar and commonplace alterations of consciousness that we experience in modern life, yet it remains inadequately explained by contemporary neuroscience and psychology. The mechanism behind highway hypnosis appears to involve a remarkable shift in cognitive processing that occurs when the brain encounters a repetitive, monotonous environment that requires minimal conscious attention. Your visual system continues to register the road, your motor cortex continues to execute the micro-adjustments necessary to keep the vehicle centered in its lane, and your reflexive systems remain alert to genuine hazards, but your prefrontal cortex, the region responsible for conscious awareness and memory formation, seems to enter a state of reduced engagement. The brain essentially becomes bored with the unchanging scenery and the predictable task of maintaining speed and direction. So it allows your conscious mind to wander into something resembling a meditative state, while your procedural memory and automatic systems handle the routine task of driving. Some researchers suggest this represents a form of automaticity, where frequently practiced behaviors become so ingrained that they no longer require conscious supervision, while others propose that monotony itself triggers a mild dissociative state, a mental mechanism that evolved to help us endure tedious and repetitive activities by essentially removing our conscious awareness from the equation. What makes highway hypnosis particularly strange from a scientific perspective is that we have essentially normalized a state in which we are engaging in a complex, potentially dangerous activity, while our conscious mind is almost entirely absent from the experience. And we accept this as a routine aspect of modern transportation without fully understanding it or grappling with the underlying paradox of how a person can operate a multi-ton vehicle competently while having virtually no memory of doing so. Beneath the frozen Antarctic ice shelf, in waters so cold that they approach temperatures incompatible with life itself, a phenomenon occurs that seems to defy the fundamental laws of physics and biology as we understand them. These formations are called brinicles, and they are quite possibly the most alien structures that exist on our own planet, emerging from the darkness of the polar ocean in shapes that resemble icicles but function as instruments of instantaneous death. A brinicle begins to form when incredibly salty, supercooled brine, which is water so saturated with salt that it cannot freeze, yet exists at temperatures far below the normal freezing point, is expelled from beneath the sea ice during the process of ice formation itself. As fresh water freezes at the surface, the salt is rejected from the crystalline structure and sinks downward in the densest, coldest form imaginable, creating a column of descending brine that is simultaneously liquid and far colder than the surrounding seawater. This descending plume of hypersaline water freezes everything it touches in its path, creating a hollow tube of ice that grows downward from the ice shelf like an inverted stalactite made of frozen salt water, sometimes reaching depths of hundreds of meters into the abyss below. What makes brinicles truly haunting is their effect on the creatures that inhabit these waters. As the extreme cold radiating from the brinicle freezes any organism unfortunate enough to be caught in its vicinity, killing fish and other marine life with such speed and efficiency that they become entombed in ice, suspended in a state between life and death that seems to violate every principle of biological preservation. The mechanism behind brinicle formation is rooted in the peculiar properties of salt water and the thermodynamic principles that govern phase changes in extreme environments. Yet despite our scientific understanding of how and why they form, there remains something profoundly unsettling about witnessing these structures on documentary footage, as they move through the water with an almost deliberate purpose. As if they are sentient entities hunting through the darkness, rather than merely physical phenomena obeying the laws of chemistry and physics. We have observed and documented brinicles thoroughly in recent decades. Our understanding of their formation is essentially complete, and yet the sense of wrongness they provoke persists undiminished, perhaps because they represent a form of death and transformation so absolute and instantaneous that it troubles something deep within our consciousness. A reminder that the universe contains mechanisms of destruction and strangeness that operate in places we can barely reach and only imperfectly comprehend. Imagine standing on the deck of a ship during a violent thunderstorm, the sky crackling with electricity and the air itself seeming to vibrate with otherworldly energy, when suddenly you notice a ghostly blue-green glow appearing at the tips of the mast, the rigging, and even the pointed ends of the crew's weapons, a phenomenon that sailors have witnessed for thousands of years and named after Saint Elmo, the patron saint of sailors and those in distress. This ethereal luminescence dances silently in the darkness, creating an almost supernatural corona of light that seems to defy the laws of ordinary fire, yet it produces no heat, no smoke, and no actual combustion whatsoever. Throughout history, mariners interpreted this apparition as a sign of divine protection, or conversely, as an omen of impending doom, and they developed elaborate rituals and superstitions around its appearance, treating it with reverence and fear in equal measure. The scientific explanation, however, reveals that St. Elmo's fire is actually a coronal discharge phenomenon in which the electrical field during a thunderstorm becomes so intensely concentrated around pointed conductive objects that it ionizes the surrounding air molecules, causing them to emit that distinctive glow we observe. The mechanism works through a process where the electric field's strength exceeds the breakdown threshold of air, creating a partial discharge that doesn't require a complete lightning strike to occur, and instead produces this continuous, luminous plasma that clings to metallic points and edges. Despite our complete understanding of the electromagnetic principles involved, despite the fact that it poses no danger whatsoever to those who witness it, the cultural mystique surrounding St. Elmo's fire has never truly dissipated, and modern observers still report feelings of awe and unease when encountering it, suggesting that our rational comprehension of natural phenomena rarely diminishes the psychological impact they carry, and that the boundary between explained science and felt experience remains remarkably permeable even in our contemporary world. Perhaps this enduring fascination reflects something fundamental about human nature itself, our deep-seated need to find meaning in the spectacular and rare, and our recognition that witnessing such phenomena, whether understood or not, connects us across centuries to countless others who have stood in awe beneath the same luminous sky, transformed momentarily by forces larger than ourselves. In this way, St. Elmo's fire becomes more than a mere atmospheric curiosity. It becomes a bridge between the observable universe and the human yearning to perceive order and meaning within it, reminding us that even in an age of scientific enlightenment, the most profound experiences often transcend the boundaries of empirical explanation alone. Imagine yourself standing in a crowded room filled with dozens of conversations happening simultaneously, a cacophony of overlapping voices and ambient noise that should theoretically render all speech unintelligible. Yet somehow you find yourself able to isolate and focus on the specific voice of the person directly in front of you, filtering out all the irrelevant chatter with what seems like effortless precision. This phenomenon is known as the cocktail party effect, and it represents one of the most curious capabilities of human auditory perception, a neurological trick that allows us to attend selectively to one acoustic source while effectively suppressing all others. In a typical cocktail party scenario, your ears are bombarded with sound waves from multiple speakers, music playing in the background, clinking glasses, footsteps, and countless other acoustic events. Yet your brain somehow manages to extract the relevant signal from this overwhelming noise and present it to your conscious awareness in a clear and understandable form. The mechanism underlying this remarkable ability involves a complex interplay between your peripheral auditory system and higher-order cognitive processing in your brain, beginning in the cochlea of your inner ear, where sound waves are converted into neural signals. But the real magic happens at higher levels of processing, where your brain employs what neuroscientists call selective attention. Your brain uses various acoustic cues to segregate the target voice from background noise, including differences in fundamental frequency, spatial location, voice characteristics, and speech patterns. And simultaneously it engages in what researchers describe as top-down attention, where your conscious intention to listen to a particular person actually modulates neural activity in auditory cortical regions, essentially tuning your brain like a radio receiver to lock onto that specific frequency. What makes the cocktail party effect so intellectually fascinating is that we have normalized this extraordinary capability to the point where we rarely pause to consider how utterly improbable it should be. How our brains perform this feat of signal processing with such apparent ease that we take it completely for granted. Yet the moment we truly think about the computational complexity involved in parsing individual voices from a dense acoustic environment, the achievement becomes almost staggering. Despite decades of research into auditory neuroscience and cognitive psychology, scientists still do not fully understand all the mechanisms involved in this selective listening ability, and sophisticated machine learning models that attempt to replicate this human capacity require enormous computational resources and still fail to match human performance in many realistic scenarios. Imagine standing on a beach or a high vantage point watching the sun descend toward the horizon on a perfectly clear evening, and in that final moment before the sun disappears completely below the line where ocean meets sky, you witness something extraordinary. A brilliant flash of bright green light that lasts only a second or two before vanishing entirely. This phenomenon, known as the green flash, has captivated observers for centuries, from sailors spending months at sea to casual travelers pausing during their sunset viewing, and it represents one of those moments where reality seems to defy the ordinary rules of light and color that govern our everyday visual experience. The green flash occurs because of the way Earth's atmosphere refracts sunlight as it passes through the densest layers near the horizon, bending different wavelengths of light at slightly different angles, which separates white sunlight into its component colors much like a prism does in a physics classroom. Because blue and green wavelengths bend more than red and orange wavelengths, they appear to shift upward just as the sun's disk touches the horizon, and for a brief instant, the green wavelengths become concentrated enough to appear as that distinctive bright green burst before the sun drops below the visible line. Yet despite this elegant scientific explanation rooted firmly in optics and atmospheric physics, the green flash remains genuinely difficult to observe for most people, requiring specific conditions including a clear, unobstructed view of the horizon, minimal atmospheric pollution, and precise timing and positioning that many casual observers fail to achieve on their first attempts. The phenomenon persists in our cultural consciousness as something almost magical, a rare gift from nature rather than a straightforward application of well-understood physical principles, and this persistence reveals something curious about human perception. That even when we fully understand the mechanism behind something, the actual experience of witnessing it can still feel transcendent and inexplicable. People who have successfully observed the green flash often describe it with a sense of awe that seems disproportionate to what is ultimately just light being bent by atmosphere, suggesting that there remains a gap between intellectual understanding and experiential reality that cannot be fully bridged by explanation alone. This gap between knowing and experiencing may explain why the green flash has inspired literature, art, and scientific obsession across cultures, why Jules Verne featured it in his novels, why physicists continue to study its variations, and why countless travelers position themselves at coastlines and mountaintops with cameras and patience, hoping to capture not just the phenomenon itself, but that transformative moment when understanding gives way to wonder. Every human being who has ever walked this earth carries upon the tips of their fingers a unique and intricate pattern of ridges, whorls, and loops that will remain essentially unchanged throughout their entire lifetime. And yet, despite centuries of scientific inquiry and technological advancement, we still do not fully understand why evolution bestowed this peculiar feature upon our species in the first place. When you examine your own fingertips under magnification, you will notice an almost impossibly complex labyrinth of raised lines and valleys, patterns so distinctive that no two individuals in the history of humanity have ever been found to share identical fingerprints, not even identical twins who share the exact same genetic material. And this statistical certainty has made fingerprints invaluable to law enforcement and identification systems around the world. The prevailing scientific explanation suggests that fingerprints likely evolved to provide enhanced grip and tactile sensitivity, that the ridge texture increases friction between our skin and objects we handle, allowing us to manipulate tools with greater precision and control, a theory that seems logical on its surface and aligns with our understanding of evolutionary pressures in early human development. However, when scientists have conducted careful experiments to test this hypothesis, the results have been frustratingly ambiguous and inconclusive, as some studies suggest that fingerprints do indeed improve grip strength in certain conditions, while other research indicates that the friction advantage is minimal and could easily be achieved through other biological mechanisms that would be far simpler to evolve and maintain. Beyond the grip hypothesis, some researchers have proposed that fingerprints might enhance our ability to detect subtle textures and vibrations, that the ridges could contain sensory receptors that allow us to perceive minute variations in surface properties that would otherwise go unnoticed. Yet this explanation also remains largely unproven and relegated to the realm of informed speculation rather than confirmed biological fact. What is perhaps most peculiar is that we have so thoroughly normalized the existence of fingerprints in our daily lives and incorporated them into our systems of identification and security that we rarely pause to consider the fundamental mystery of their purpose. Accepting their presence as simply another unremarkable feature of human anatomy, rather than questioning why our fingertips display this remarkable and distinctive architecture, when smoother skin would seemingly serve most practical functions just as effectively, if not more so. In a remote valley in central Norway, nestled between steep mountains and dense forests, lies a small village called Hestelen, a place that has become synonymous with one of the most persistent and documented phenomena of unexplained luminous activity in the modern world. Beginning in the early 1980s, residents of this isolated community began reporting strange lights dancing across the night sky with remarkable frequency, appearing sometimes multiple times per week, creating an unusual concentration of sightings that would eventually attract international scientific attention and generate thousands of documented observations. These lights typically manifest as yellowish or reddish orbs that move with deliberate, intelligent-seeming patterns through the atmosphere, sometimes hovering motionless for extended periods before accelerating at speeds that would challenge conventional aircraft capabilities, and occasionally splitting into multiple smaller lights that seem to coordinate their movements in ways that defy easy explanation. The phenomenon reached such intensity during certain periods that local residents began systematic documentation efforts, and by the 1990s, the Norwegian University of Science and Technology dispatched researchers to establish the Hestelen AMS, an automated monitoring station equipped with cameras, magnetometers, and spectrographic instruments designed to capture whatever physical evidence these strange lights might provide. Scientists have proposed numerous rational explanations over the decades, ranging from ball lightning to plasma phenomena, unusual atmospheric reflections of distant car headlights or mining operations, or naturally occurring piezoelectric effects in the mineral-rich rock formations surrounding the valley. Yet despite decades of serious investigation and the mounting evidence that should theoretically solve the mystery, the lights continue to appear with regularity that seems almost independent of scientific scrutiny or public awareness, neither increasing nor decreasing in frequency regardless of the level of attention directed toward them. What makes Hestilin particularly intriguing is not any single spectacular sighting, but rather the sheer mundane persistence of the phenomenon, the way it has woven itself into the fabric of a small community that has learned to coexist with mystery, accepting the nightly displays as simply another characteristic feature of their landscape, much like the mountains or the forests. A reminder that some portions of our physical world continue to resist complete categorization despite our sophisticated instruments and accumulated knowledge. Consider the peculiar phenomenon wherein a patient visits their doctor with genuine physical complaints, receives a prescription for what they believe to be an active medication, and then experiences a worsening of their symptoms despite the fact that the substance they were given contains absolutely no therapeutic compounds whatsoever. This is the nocebo effect, and it represents one of the most unsettling inversions of the placebo response that science has documented, demonstrating that our minds possess a remarkable capacity to harm our own bodies through nothing more than expectation and belief. Unlike the placebo effect, where positive expectations can genuinely improve our physical condition through neurobiological pathways, the nocebo effect shows us that negative expectations and fear about treatment or medication can actually trigger real physiological deterioration, pain intensification, and symptom manifestation in ways that seem to defy our understanding of how consciousness relates to bodily function. The mechanism underlying this phenomenon appears to involve the complex interplay between our anticipatory systems and our neurochemical regulation, wherein the expectation of adverse effects activates stress responses in the body, including the release of cortisol and adrenaline, increased inflammatory markers, heightened pain perception through altered neurotransmitter activity, and even changes in immune function that make us genuinely more susceptible to discomfort and illness. When a patient is told that a medication may cause headaches, nausea, dizziness, or other side effects, their brain doesn't simply file away this information as neutral data. Rather, it begins actively monitoring their body for these exact sensations, amplifying normal bodily signals and misinterpreting ordinary physical variations as evidence of the predicted harm. The brain becomes primed to notice and magnify any sensation that could remotely be construed as matching the expected symptom, creating a self-fulfilling prophecy where vigilance itself produces the very suffering that was feared. What remains profoundly mysterious is the degree to which this phenomenon persists even among individuals who intellectually understand that they have received an inert substance, suggesting that conscious knowledge of deception provides surprisingly little protection against the nocebo response, and that our deeper neurobiological systems operate largely outside the reach of rational awareness and deliberate control. This disconnect between what we consciously know and what our bodies experience reveals a humbling truth, that we are not unified rational agents commanding our physiology, but rather collections of competing systems where ancient survival mechanisms can override our modern understanding, making the nocebo effect not merely a curious medical oddity, but a fundamental constraint on the limits of reason's dominion over flesh. Have you ever noticed that when something is almost human but not quite, it disturbs us in a way that's difficult to articulate or explain? Consider the experience of watching a humanoid robot that moves with precision, yet lacks the fluid, unpredictable qualities of genuine human motion, or observing a computer-generated character in a film that possesses remarkably realistic facial features, but something essential remains missing from its expression. This phenomenon creates a peculiar sense of unease that intensifies precisely as the artificial entity becomes more lifelike, yet paradoxically diminishes once it achieves complete realism. We find ourselves comfortable with overtly artificial representations, accepting cartoon characters and simple robots without hesitation, and we feel equally at ease with actual human beings, yet there exists a strange middle ground where our comfort collapses entirely. This is the uncanny valley, a psychological phenomenon where objects that are nearly but not perfectly human trigger profound discomfort and revulsion in most observers. The mechanism underlying this response appears to be rooted in evolutionary survival mechanisms and our finely tuned ability to detect deception or anomaly. Throughout human history, our ancestors developed acute sensitivity to subtle signs of illness, death, or fundamental wrongness in other individuals, as recognizing these markers could mean the difference between safety and exposure to disease or danger. When something appears almost human, our brain activates this ancient warning system, searching frantically for the wrongness it intuitively senses but cannot quite identify, creating a state of cognitive dissonance that manifests as profound unease. The valley exists because our acceptance scales in two opposite directions. We accept increasing artificiality as long as it remains obviously artificial, and we accept increasing realism as long as it achieves convincing completeness. Despite decades of research into artificial intelligence, robotics, and computer graphics, we have not yet managed to cross this valley entirely, and the most advanced humanoid robots and realistic digital humans still trigger this response in most people, suggesting that the uncanny valley represents something fundamental about human perception that cannot be easily engineered away or explained through simple logical reasoning. Perhaps most intriguingly, this suggests that our sense of humanness extends beyond mere physical resemblance to encompass something more intangible, a quality of aliveness or authenticity that our minds recognize instantaneously, yet our language struggles to describe, leaving us capable of feeling profound revulsion at what we cannot fully explain. As you move through your life, your memories do not distribute themselves evenly across your years, and this uneven distribution reveals something peculiar about how human consciousness organizes its own past. When researchers ask people of various ages to recall significant life events, memories from adolescence and early adulthood show a remarkable clustering, a peak in recall that psychologists call the reminiscence bump, and this phenomenon emerges consistently across cultures, languages, and demographic groups in ways that suggest something fundamental about the architecture of human memory itself. A person in their 60s will remember more details from their teenage years and early 20s than from their 30s and 40s, not because those earlier years were necessarily more eventful, but because something about the human mind privileges that particular window of life with enhanced encoding, storage, and retrieval capacity. The reminiscence bump typically occurs between ages 15 and 30, with the strongest memories clustering around ages 18 to 25. And during these years people graduate, fall in love for the first time, establish their adult identities, leave their childhood homes, and encounter a cascade of novel experiences that feel subjectively significant in ways that midlife routines often do not. Neuroscientists and psychologists have proposed that this phenomenon may result from the intensity of novelty and emotion during adolescence and early adulthood, when the brain is still undergoing significant development and every experience feels fresh and world-altering in a way that later repetitions rarely achieve. Additionally, these years represent a critical period for identity formation, when people are actively constructing who they are and will become, and memories that contribute to that construction process receive priority in the brain's filing system as if the mind recognizes their foundational importance. The bump persists despite our rational understanding that our 30s and 40s contain equally significant experiences, equally profound relationships, and equally transformative moments. Yet somehow those middle decades of life seem to fade into a kind of gray blur in retrospective memory, while adolescence remains vivid and detailed. We have normalized this strange asymmetry in our own autobiographical narratives, rarely questioning why our sense of who we are seems disproportionately rooted in what happened before age 30. Why the person you were in college continues to feel more vividly real than the person you became in your career, and why some researchers suggest that for many people, the story of the self essentially concludes its most memorable chapters before midlife even truly begins. For decades, scientists sequenced the human genome and discovered something that fundamentally challenged their understanding of genetic inheritance, and they called approximately 98% of our DNA non-coding, meaning it does not directly produce proteins or appear to have any obvious biological function whatsoever. This vast expanse of genetic material sits within our cells like an enormous library of unmarked books, and despite comprising the overwhelming majority of our genetic blueprint, it remains one of the most poorly understood aspects of human biology. The psychological impact of this discovery created a peculiar cognitive dissonance where scientists confidently asserted that this DNA was essentially junk or evolutionary baggage, yet simultaneously admitted they did not truly understand what it did or why our bodies maintained it across millions of years of evolution. The mechanism behind this phenomenon appears rooted in our historical approach to biology, where researchers focused intensely on protein coding sequences because they could be studied directly, measured, and their functions observed in laboratory conditions, while the non-coding regions seem to resist easy categorization or explanation. Over time, accumulating research has revealed that non-coding DNA actually performs countless regulatory functions, controlling when genes turn on and off, influencing chromosome structure, producing RNA molecules with specialized purposes, and potentially containing information about developmental processes we have barely begun to understand. Yet despite this growing evidence that non-coding DNA serves critical roles in biological function, the original designation persisted in scientific literature and popular understanding, creating a situation where what was once labeled junk remained casually dismissed, even as researchers discovered its elaborate complexity. The normalization of this contradiction reflects something profound about how scientific communities operate, where initial frameworks and terminology achieve such institutional momentum that they continue circulating long after contradictory evidence accumulates. And changing the language would require acknowledging that a generation of scientists operated under a fundamental misunderstanding of life itself. This resistance to linguistic revision extends beyond mere semantic preference. It represents a cognitive anchor that shapes which research questions scientists prioritize and which discoveries they choose to emphasize or downplay, suggesting that the language we use to describe nature actively constrains our ability to perceive it clearly. Consider the peculiar anatomical feature that extends downward from the lower jaw of human beings, a bony protrusion that appears to serve no obvious biological function, yet exists in virtually every member of our species with remarkable consistency. This is the human chin, and despite centuries of scientific inquiry, researchers remain genuinely uncertain about why we possess this distinctive feature at all, particularly when compared to our closest primate relatives who lack any comparable structure. The chin is not a vestigial remnant of evolutionary development, nor does it appear to be necessary for basic survival functions like eating, speaking, or breathing, yet it remains one of the most defining characteristics of human facial anatomy. When we examine the fossil record of human ancestors stretching back millions of years, we find that the chin is a relatively recent development, emerging only within the last 100,000 years or so of human evolution, which means that for the vast majority of our species' existence, our ancestors possessed faces without this prominent feature. Scientists have proposed numerous theories to explain the chin's existence, suggesting it might relate to structural reinforcement of the jaw, sexual selection and mate preference, or perhaps a byproduct of changes in facial bone growth patterns unrelated to any specific advantage. Yet none of these explanations has achieved definitive consensus within the scientific community. The psychological mechanism at work here involves our tendency to assume that every persistent biological feature must have evolved for a reason, that natural selection would not preserve something without clear adaptive value, and yet the human chin may represent exactly this kind of evolutionary paradox. We have normalized the existence of the chin so completely that most people never question why it exists at all, accepting it as simply part of what makes us human, yet this normalization masks a profound gap in our understanding of our own bodies. The chin remains one of those fascinating reminders that human evolution is far more mysterious than we often assume, and that the very features we find most characteristic of ourselves may persist for reasons that science has yet to fully comprehend. Perhaps this uncertainty itself is instructive. It suggests that not every aspect of human anatomy requires a grand evolutionary explanation, and that some features may simply persist because they pose no significant disadvantage to survival or reproduction, reminding us that evolution is less a process of optimization and more a process of acceptable variation across generations.